Hello, hello. Apologies, I'm a bit late. There might be some disruption to the stream, but hopefully, it goes okay. I need to check one. Hang on. Okay, I think we're good. Yes. So before we're going to continue with this paper, June 2023. But first of all, I did want to comment on a minor uh, correction on one of the questions we did yesterday or last stream. And it's this inequality question. So, just a minor one, but we have a strict inequality here. Uh, a strict inequality here. So what you should do with a strict inequality, the line or whatever, or the locus, it has to be dotted. Okay, so it has to be like this. It shouldn't be a full on straight a filled in line. Because that's say it's greater than or equal to, less than or equal to, so it includes the point on the line. When it's dotted, um, then it's strictly less than. So what I should have done here with this bisector, which is the locus, uh, it needs to be dotted. Okay, so not filled in, but it should be dotted. Okay, I just wanted to go over that. But everything else should be okay, hopefully. Unless, and obviously, if you spot anything, let me know. But yeah, we're gonna quickly because I don't have a lot of time, but I do want to get through the rest of the paper to not leave anyone hanging. I do ideally want to do paper two as well because there's some interesting questions on that. But let's just get through this paper first. Uh, so it's a vectors question. So we're given a line L1, which is in Cartesian form. We're given the plane, and we need to find the point of intersection between the line and the plane. Well, very simply, we need to equate them together. So what you should know via the formula book, we are given the Cartesian equation of a line, which is over here, right? This part here. That's in the form we have. However, notice this is equal to lambda. So obviously an equation of a line is written in this form. So R equals a point P that we know is on the line plus lambda D. So D is a direction vector and we have scalar multiples. This lambda here, every single of these are one of these fractions is equal to lambda. Okay. So what we can do then is essentially there's like four equations almost. So we can say x plus 5 over 1, so that's just x plus 5 equals lambda. We also know y plus 4 divided by minus 3 is lambda. And z minus 3 over 5 is lambda. Okay, so what can we do? Well, we were also given this equation of the plane here, right? So because we have expressions for x, y, and z in terms of lambda, I think we can rearrange for x, y, and z in terms of lambda. That's lambda minus 5. And then y would be minus 4 minus 3 lambda. All times by minus 3 and minus 4. And z would be 5 lambda plus 3, so 3 plus 5 lambda. Okay, and then what I think we have is plane is, if we remind ourselves, the plane equation is 2x, sorry, plus 3y minus 2z equals 6. So what I think we can do is substitute x, y, and z into here, so we get lambda only. We can solve for lambda, and then obviously we can substitute back into x, y, and z to get the coordinate of the intersection, the point. So therefore, 2 lambda minus 5 plus 3 lots of 4 minus 3 lambda minus 2 of 3 plus 5 lambda is 6. And then we can expand it out. So 2 lambda minus 10 plus 12 minus 9 lambda minus 6 minus 10 lambda equals 6. And then let's group it all together. 2 lambda minus 9 lambda minus 10 lambda would be minus 17 lambda. And minus 10 plus 12, that'd be 2. 2 minus 6 minus 4. And that equals 6. And then lambda would be, add 4 to both sides, 10 divided by minus 17, which would be, wow, it's just that really, 10 over, well, that's really it essentially, minus 10 over 17. Look at what we can do there. The calculator doesn't simplify it anymore. Hang on, let me just have my light on. Okay, and now let's substitute lambda into x, y, and z. Therefore, oh dear. Therefore, x is minus 10 over 17 minus 5, which is apparently minus 95 over 17. Check that actually. Let me double check. These are quite odd fractions. Let me have a check. X plus 5 is lambda. Y plus 4 over minus 3 is lambda. Z minus 3 over 5 would be lambda. So x would be lambda minus 5. Y would be minus 3 lambda minus 4. Ah, that's okay. So there's a negative issue there. So that's minus 4. Yeah, okay. And then Z would be 5 lambda plus 3. Yeah, okay, I did, yeah, I thought there was a bit weird there with the fractions and stuff. Okay, so it's expanded, so we did most of it already, so minus 4 instead of 4 here. I didn't see the minus here, my own work, my own writing. So that'd be minus 12. Minus 9 lambda. Okay, so that'll still be minus 17 lambda, but this would be minus 10, minus 12, minus 22. That'd be minus 28, which would be 6, right? Let me check. Okay, everything else looks to be okay. So then lambda would be 34 over 17, right? Which is a lot nicer. Uh, no, minus 34 over 17, which is minus 2. There we go. That's a lot nicer, right? There we go. Bloody negatives. Anyway, x is lambda minus 5. That's minus 2 minus 5. That'd be minus 7. Y would be 4 minus 3 lambda. So 4 minus 3 of minus 2. That'd be 10, right? 4 add 6. And Z would be 3 plus 5 lambda. That's 3 plus 5 of minus 2, which would be minus 10 add 3. That'd be minus 7. Therefore, point has to be minus 7, 10, minus 7. Cool. A bit of work, only for 2 marks there. But there we have it. Okay. Hopefully that makes sense. But anyway, I'm going to move on quickly. So we're given that L2 is a reflection of the line L1 in the plane pi 1. So it's kind of looking like this. So this is our plane. L1 would look like this, and then L2 would be the reflection. Okay. Uh, no, it wouldn't. Sorry. This would be L2. So obviously you go there. L1 would continue through there, but that's what the reflection would look like. Okay. Okay. So reflection of the line L1 in the plane pi 1. God, God's sake. Uh, and it says show that a vector equation for L2. So essentially, we need to find what this reflected line is, essentially, which is quite a standard exercise, but the textbook doesn't go over it very well. Again, if I go on to make topic videos at some point, I'll definitely be covering this a bit more in detail, but I'll go over it now as this is an example. So, okay, so we need to reflect L2 in L1. So let's have a look at this diagram here. So for every vector line, obviously every vector line is going to look like this. So a point that we have plus lambda d. Well, we already have lambda, so I'm going to call it, well, no, I can call it lambda actually. But if, it'll be a different lambda. No, actually, mu. There we go. That's mu. That's in the question. Okay, so it has a point that we know is on the line and the direction vector. But actually, we already know a point on the line. Because if you, as you see here, this is L2, which reflects to L1, as you show. This intersection point on the plane, that also lies in L2. But did we not already work out in part A the point of intersection here between L1 and the plane? And was that not minus 710 minus 2? Uh, but we've clearly gone wrong here, actually. And it's, again, with part A, because it's minus 7, 2. So the y component should be 2, not minus 10. So actually, the question was quite nice because it allows us to check part A. And clearly we need that because, again, we've gone wrong somewhere. How? 2x plus 3y. Y is, might be, yeah, we already covered that. So the lambda is right. So that means this bit should be wrong, is wrong then. So y would be minus 4. That's y. Minus 4 minus 3 lambda. So that would be 6 minus 4. That would be 2. There we go. Which is what we get in the okay, again the negative lot. It's because of my handwriting on the paper, so I can't see as well. I know I keep saying. I know it probably sounds like I'm chatting shite here, but I'm telling you, if I was in the real thing, uh, it'd be a lot easier to write on paper, and I could see the negatives more. But yeah, so I guess that's the thing to learn from this as well. Exam technique. Really make sure your writing's clear so you can pay attention to negatives where they are. Okay, but that was a nice question. It allowed us to check. So at this point already lies. So we found P, because that's part A, right? The intersection L1 on the plane, but that's where L2 meets with L1. Okay, so that's a point on L2. And so then really all we need to find is the direction vector. Um, Now the direction vector, there are two possibilities. You can either deduce something about the plane, and then if L2 is perpendicular or parallel to the plane, um, then you find the direction vector, right? So, but here there's nothing we can deduce. L1 is at an angle theta. Uh, it's not neither line is parallel or perpendicular. L2 doesn't lie on the plane. It's not perpendicular. So there's nothing we can really immediately deduce. So then what's the other way? Well, the other way, how do we compute direct vectors is to take the difference of 2 points, right? That lie on the line. So what we need is to find a different point on the line, okay? And then what you can do is say this is Q, and we know this is P. The direction vector will be PQ, right? Which should be Q minus P, right? The position vectors. So that's the other way to find the direction vector. So we can find another point on the line L2. Then actually, because we already know another point, which is here, the intersection. If we then find another point, well, we can take the difference, and that'd be our direction. So then the main question is, how do we find another point on L2? So I'm going to just write this bit down, what we just done. So L2, a generic point, plus mu d, general equation of a line, of a vector line, I should say. L2 intersects L1 at pi 1. So P is equal to 7 minus 7 to minus 7 from pi A, right? For the reason we just said. So therefore, L2 would be minus 7, 2 minus 7, plus mu of a direction vector d. So that's where we got to. So now we need another point. So, again, I'm going to draw this situation we've got here. So L1 is there, and then L2 would look like that. That's the reflection in the plane. Okay, so we know that this is P, this intersection point. Now we need another point Q. Okay, so how do we do? How can we do this? And again, hopefully, if you like the methodology, you should be able to do that quite quickly. But I'm going to go over it. Hang on, I might need to sneeze. Oh man, that was long, man. Well, what you can do is consider reflecting the point instead of the line as a whole. So if we take another point at Q dash, if we then reflect it into Q, if we then reflect it on the plane, and then we've got the mirror point, the reflected point. So Q is the reflection of point. Actually, no, it would make more sense to say Q dash, right? Because it's a transformation, right? The transformed point is a Q dash. So Q dash is a reflection of Q on the plane, right? So then, if you also remember from GCSE, or in general, I guess, if you reflect a line on a mirror line or anything like, or a reflection on the line, if you reflect the point, so say this is Q, it is the same distance between the line and the key point is its perpendicular. So it's the perpendicular line distance between so it's kind of like perpendicular bisectors again, like we did last time. So the reflected point, obviously the line that connects the 2 points, will be perpendicular to the plane pi 1, and it's equal distance. So it's kind of like a perpendicular bisector. So a reflection of a point on the original line forms a perpendicular bisector with pi 1. Okay. And that will always be true for any reflection of a line. So actually, we can make use of this, can't we? Because is this not also another line we can easily compute? Because this is a perpendicular vector to pi 1. And we know that a what the perpendicular vector of any line is. And it's this when it's in this form, isn't the vector just a, b, c, which we already had this form given to us. So I think if we find the equation of this given line and any point on the line, say on L1, I think we can then find the equation of a line and then find Q dash. And I'm going to go over it. So let's choose a point Q on L1 to be reflected. Okay, any point. So how do we do? Well, actually no. Hang on. So now that point there is perpendicular. No, sorry. Yes, let's choose a point at Q and L1. Well, the easiest way to do that, well, we know what the equation of L1 is, and that's equal to lambda. Why can't we just set lambda to be any given number? And I think the best way is to choose lambda as 0. So really, if you want to find any point on L1, well, you just choose any given direction vector. So let lambda equals 1, 0, for instance, okay? To show that it doesn't really matter what value we pick. Therefore, x would be, well, we know the equation, well, we know the equations, right, of the line, which we did in part A. So x plus 5 is lambda. So if lambda is 0, then x plus 5 is 0. So that means x would have to be minus 5. And likewise, y would be y would be 4 minus 3 lambda. Well, that would be 4. And then z would be 3. Okay. No, y is minus 4. God, I did it again almost. Y is minus 4 and z would be 3. Cool. So therefore, Q would be minus 5, minus 4, 3. And that's just a point we plucked on L1, any point at all. But the most simplest choice is lambda 0, because it makes our life a lot easier. Don't be a smart ass and try to pick lambda like 1,259,000 or something. Just be simple there, okay? But yeah, so there we are. So you have a Q. So you have a point Q, and we're going to reflect this using this diagram here. So we know a point on we know a point now on this line that we're going to connect from Q to Q dash. So therefore, line of Q to Q dash. So the line Q dash is in the form R is minus 5, minus 4, 3, plus another value T, right? T with a direction vector D. Okay. So that's a general equation of a line. But actually, like I said, just discussed, we also know what the direction vector would be, because as I said, the key feature is that if you reflect the line at a point in the line, it has to be perpendicular. So it's a perpendicular bisector pretty much. So the line connecting the reflected point to the original point, it goes through the plane at a perpendicular, a right angle. Okay. But we know how to find very easily the direct perpendicular vector of a plane. And it's just 2, 3, minus 2. Minus 2. Why did I say minus 4? Minus 2. And that would be our direction vector. So actually, we found the line very easily. 2, 3, minus 2. Cool. So now we can kind of substitute to find q dash. But then, like, well, how do you know what value of t to substitute then to find q dash? And that's where the other key point is. These are equal distances apart, okay? And that's the whole idea, right, of a reflected image. It's the same distance away from the mirror line or the reflection. So I think if we then find what value of t, so this occurs at t0, because obviously we defined the point to be the initial point here. And so when t is 0, you get this point here, which is at q. I think what we could do is this intersection point. What value of t would give this intersection point, which we know found in part A, between pi1 and L1? And then I think we could just double it to get to q dash. So the distance, get from t0 to t of this, we can then double it to get to the distance here, because it's the same distance on the line. So that's, again, that's really all we need to do now. So remind ourselves the point on the intersection is -7, 2, -7. Intersection point between L1 and pi1 is -2, 7. No, it was -7, 2, -7, wasn't it? I believe. So therefore, what we're going to do, so to find t, we're going to substitute this as r, because this is a point on the line as well. Uh, so this is a point, and we need to find it in terms of t, and then we can combine the vectors together. So it's going to be 2t minus 5, 3t minus 4, and minus 2t plus 3. And we can simply equate them together. Any line. So because we also know this intersection point, again, as I said, is a point on the line. So we know that the intersection point is also on the line. So we don't have to worry about whether or not the equations are consistent. They should be, because how we constructed it. So let's just pick any one. I think this one, the middle one, looks the nicest. So let's say 2, not 2t, 2. So 2 has to be 3t minus 4. And therefore t would be 2 plus 4, which is 6. So 6 over 3, which is 2. Therefore, q dash lies on the line when t is 2 times 2, which is 4. So let's have a look at that again, just to make ourselves clear. We found then that this point occurs on this line QQ dash, the bisector, when t is 2. So we've gone from 0 here, from Q to the plane in 2, okay? So then to get them from the plane to Q dash, we're going to have to do another 2. So this is going to occur at t equals 4. So then we equate t4 into this line here. I think we get q dash. So therefore, q dash is what line do we have? -5, -4, 3. Plus 4, lots of, what's the direction? 2, 3, -2. And once we compute that, well, that's q. So that's just a bit of vector addition. So add column y, so -5, add 8, so that'd be 3. -4, add 12, which should be 8. And then 3 minus 8 would get you -5, would it? Okay, and that's q. So that's q. We're not done there because the original question, the original part was finding this equation for L2. Okay, what we've found here, this line equation, so that's L2. What we've found here, this line, is the bisector connecting Q to Q dash. The whole idea of this exercise was to find Q dash, a point on L2. Because now what we have is 2 points on L2. Because remember, the other point is the intersection point. Okay. Um, um, so yeah, so the direction vector is the difference of two. So it's going to be Q dash minus the intersection point, which was P, was it? I can't remember what we called it now. So it was Q dash minus P. There we go. So P was the intersection point. P is minus 7 to minus 7. Which is 3, 8 minus 5, minus P, which was 2, minus 7, sorry. 2 minus 7. And that's going to be 3 add 7, 10. 8 minus 2, 6. Minus 5, was it? Yes. Minus 5 add 7. That's 2. And okay. So therefore, L2 then, if you remember, is minus 7, 2 minus 7, add mu of this direction vector, which is 10, 6, 2. And what you can do is, you can, oh God, it's the end of the paper. I'm going to need more paper then. I'll do that in a second. And what you can do, you can kind of simplify the direction vector. So you could say that's minus 7 to minus 7, and then 2 is the common factor. So you could say 2 mu of 5, 3, 1. But obviously 2 mu is still a constant, so we could still just call this mu, essentially. The direction vector doesn't matter how you scale it, as long as you get the actual direction, okay? So that should be our answer. What's the answer then? What direction do they want? It was, oh, 10, 6, and 2. Okay, so that was right then, but we did need to scale it down. Um, so yeah, so that's the answer. Cool. You can leave it in either form, it doesn't matter. What I am going to do then, I didn't realise I didn't give you that much little space, or probably because I wrote big. And I wrote more than I should have, just to purely explain the idea. Okay. So let's do the other part of the question. But yeah, it's a nice 5 marks there. It's a nice 7 marks though for vector question. And look, I think reflection. I remember when I did this, reflection is really awkward, and I think a big part of that is that the textbook or whatever doesn't explain it very well, or indeed not often at all, to be honest. But that's a general approach. Okay, that's how you should be thinking about those reflector questions. They rarely come up. I think they've only come up once or twice, but it's still nice to do them. Okay, so I guess I'll just run through that one more time. So once you think about the whole idea, really, hopefully, then it should make sense of what to do. It's quite a lengthy mechanism, quite a lengthy process. It's 5 marks, usually not 7, to be honest, because of that take that much time. But I think it's fun because you already found intersection points. So uh, between L1 and the plane, that's part of the ingredient. So that cuts out some of the work. Okay, so look, the idea. So if we want to reflect a line in the plane, so L1, the reflection is L2, it would look like this. And so what we need to find is for any line is a point on the line and the direction. And the direction can be found by finding another point on the line and then subtracting the 2 points together to get the direction. Okay, but the point on L2, well, it will still intersect pi1 at the same point as L1. That's the whole idea of a reflection. If we reflect the point that's already on the plane, it will remain the same. It's an invariant point. So the same point of intersection between the original line and the plane will also be on L2. So That's how you find 1 point. And then we just need to find another point for the direction vector. And to find that, we do this. So you consider just any point on the L1 and then reflect it by noting this. So if you reflect a point on L1, again, just pick any scalar to find any point on the line. Lambda 0 is often the easiest, but it depends. Then you can find the original point and reflect it by noting this. So it's a perpendicular bisector. So it goes through the plane like this. So it's perpendicular to the plane and it's the same distance apart. Okay. And that's essentially what we use here. So once you found, you can find an equation of this bisector connecting Q and Q dash. So you find the line, a vector that's containing that it connects the 2 points. Note that the line has to be perpendicular to the plane. And we also should know what the perpendicular vector of a plane is. The Cartesian form, obviously ax plus by plus c, z is d. Wow, it's going to be a, b, c for the polar. So that's for the perpendicular vector, so that will be given. Okay, now once you've found the line equation, and then you can find the intersection point, the scalar multiple that gives the intersection point, and then double it to get q dash. Okay. Then once you found q dash, where you found 2 points, then subtract the intersection with the q, subtract the 2 points to get the direction vector, and there you are. Okay, I know it's a lot, but that's the general process of it. But cool. So then the plane L2 contains the line L1 and L2. Okay, what is going on here? So this can be question 5C. So determine the vector equation for the line of intersection of pi1 and pi2. Okay. So again, what we're going to note is a vector equation is going to be p plus, I'm not going to call it lambda, I'll call it, I should have called it, plus k, there we are, plus k of direction vector d. And again, that's a general equation of a vector line, right? So then the whole idea is to find a point on the line and d. Okay. So it's only 2 marks, so you shouldn't have to think that much or do much work. So, so the line of intersection of pi1 and pi2. Well, pi2 contains the line L1 and L2. Okay. So it's going to look like this. So L1 would be like there, and L2 would be like there, and stuff like that. Okay. But we also know pi1 intersects L1 as well. So because all of L1, actually it's not the best diagram to show it actually. When a line is contained in a plane, that means all of the line is on the plane. So none of it, because obviously the plane would go out indefinitely for infinity. So actually, in theory, he's doing it injustice by giving like an end length. It kind of looks like this. So it goes on for infinity. So therefore, the line will always be in the plane. So remember, the way we construct a plane is by taking two parallel lines together to form a plane. And that's what's happening here. So the whole of L1 is on the plane, but we know pi1 and L1 intersect. So what that means is actually pi2 and pi1 intersect at the same point that we found in part A. Because if every part of L1 is in pi2, then whatever is happening between pi1 and L1 when it intersect has to happen in the plane pi2 as well. Okay, so 1 point 1 point on the line pi two, on the on the 1 point on pi two, sorry, would be what? They're the same as pi a. Okay. But it's asking us for the vector equation of the line of intersection between pi one and pi two. Okay. So I guess that's something like this, maybe. No, rubbish example. Um, but I'm thinking one way we could find the equation of pi two, but I'm not sure where that would get us. Because if you know both the direction vectors of L1 and L2, because we found L1 and L2, then it would just be the addition of the parallel vectors. So pi 2 would be a point, which we know is, uh, what was it, 7 minus 7, 2 minus 7. Add the individual direction vectors, that'd be lambda 1 of the direction vector of L1, which was I. Oh, it's here, right? So the direction vector would be so in Cartesian form. So the direction vector is the components on the bottom of the fraction. So it would look like 1 here. So direction vector is 1 minus 3, 5. Plus lambda 2 of the direction vector of L2. Because if to reiterate, and it's in the formula book as well, you can find the equation of a plane if you know two lines are contained in a plane. Well, you can find the equation of a plane by finding the point on the plane, which was part A, as we discussed, and you take the multiples of the two direction vectors, which become the direction vector of both lines. Okay, so that's the direction vector of line one and direction vector of line two. So that's the equation pi two. But would that help? And also, do we need to do that? So, but it's asking us for the vector equation of the line of intersection of pi one and pi two. If we found these two lines, equations of pi one, pi two, would that make life easier? I don't know. Um, uh, well, I guess think about it, right? A vector equation. So pi one and pi two intersect at a line. They don't intersect at a point. So they share a common line between them. Okay. But we already said that hmm, L1 crosses with pi 1. So that means pi 2 and pi 1 cross with L1. Okay. Uh, hmm. Um, hmm. So I guess. I am back. Sorry, massive apologies, but something came up. But I'm back now. Also apologies. I didn't realise the chat was active. I don't expect that normally, but I do apologise for missing stuff. Let me just address some of the comments before we get back into it. Where's my pen? Where is my pen? Um, Keep it up, man. Thank you ever so for that. Uh, you did do way better than I did last year. Uh, is anyone doing this tomorrow, by the way? If you're here, let me have a look. Do you think a reflection question will come up this year? It came up in 2023. Obviously, this is the paper. This is. They don't ask it very often. I'll say that. Um, so I'll say not likely, but I don't think it's the worst thing to practice. Like I said, I've just gone over like the methodology of how to do a reflection question, but but I don't predict it if I'm honest. What I do predict is obviously the standard. So I predict a complex numbers question will come up. I predict a differential equation will come up. A proof by induction question, a vectors question, volumes, volumes revolution, but that could come up on either paper. A series question. So there's a few topics where that will come up, mostly in every paper, because complex numbers are the massive topics, so differential equations. So yeah, stuff like that, but specifically reflections, I would say unlikely. But yeah, hopefully everyone else doing okay though. Yeah, I do apologise. I did just step out for a little bit, but I'm back now. So yeah, where do you get on to? Discussing an intersection line of two planes. Well, oh God, let's go back here. Well, I guess another way you could look at it. I didn't want to go through this method, but I do think this is the most intuitive way, unless someone else has any ideas. Well, consider this. If you have a line that is on two different planes, pi 1 and pi 2, well, if the line is contained in the plane, as we discussed, it will be perpendicular to the perpendicular vector of a plane, right? So obviously, if you have a plane that looks like this, and then you have the normal vector, which is perpendicular. And the way a perpendicular vector is designed is obviously you've got two lines with two direction vectors. They're both going to be perpendicular to each of these direction vectors. So in other words, L1 and L2, which is on plane 2, for example, they're going to be parallel to the plane, which then means it's going to be perpendicular to the perpendicular vector. Now it's saying that the intersection line is on, or if it's the full line, so it's going to be contained in both plane 1 and plane 2. Okay. So what does this mean? Well, if we can find the perpendicular vector of both pi 1 and pi 2, um, we can find the direction vector of L1 because it's going to be perpendicular to the perpendicular vector of both. Okay. Um, so that's screaming cross product, which is actually an FP1 topic, but I do actually want to go over it because I do think it's such a huge and beneficial topic to learn, and it's not that complicated in my opinion. I don't know why they don't include it in the core section, but I'll go over it. Yeah. So the idea of a the cross product is it gives you a perpendicular vector that's parallel perpendicular to two different vectors. So it's the determinant of this the type of matrix. So A1, B1, So I'll say perp vector, right? C1, A2, B2, C2, where A1, B1, C1, they are the perpendicular, they are the vector components of vector 1, and A2, B2, C2 is the vector components of another vector C2. Now, what this vector, you'll get a vector out of this, okay? That's what ijk at the top gives us. This vector, as a result of this determinant, will give us a vector that's perpendicular to both vectors. So why does this come into play? Well, like I said, if we can find the perpendicular vector of pi1 and pi2, that means L1 has to be perpendicular to both. Well, to make sure how do we find a perpendicular vector to two vectors? It's this cross product. So I think that makes our life a lot easier. To do this sort of question. So then I guess, well, what's the perpendicular vector of pi1? Well, it's given in the question, isn't it? We did it earlier. Do, 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 It's this, right? 2, 3 minus 2. Okay. And then the perpendicular pi2. Well, they haven't given us pi2 explicitly, have they? But we know pi2 contains two lines. So actually, if we know the direction vector of the two lines, which we've actually already done here, we can use the cross product to give us a perpendicular vector to these these vectors here. And actually, that will be the perpendicular vector for pi2. So actually, to find perpendicular vector of pi2, that's going to be the, and again, there's probably multiple ways of doing this, but I think this is the most like systematic way of doing it. And yeah, so it's going to be the perpendicular of these two vectors, right? So this is direction vector of L1 and the direction vector of L2. So I guess to reiterate, if you have two vectors on a plane, the normal, the perpendicular vector of the plane, is going to be perpendicular to each of the two lines, right? So that's what we're doing here. So we found the direction vector of L1 and L2, which were in the earlier parts of the question. So that's 1, minus 3, and 5. So 1, minus 3, 5 here. And L2 was 10, 6, and 2 here. Okay. And actually, this is just computing a 3 by 3 determinant. Don't be put off with the IJK, but if we just calculate determinant of normal, that would be I of minus 3, 5, 6, 2, plus J of 1, 10, 5, 2. No, that'd be minus K, sorry, wouldn't it? Minus J, and then plus K of 1, 10, minus 3, 6. And then that would be I of minus 6 times, and then minus 30. Minus J of 2 minus 50, plus K of 6 plus 30, which goes to minus 36I, plus, so that'd be minus 48, add another minus, that'd be 48J, plus 36K. Okay, and again, as this is, oh, I need to create another one. Why does it only give me one page? I don't know. Well, obviously, as this is a perpendicular vector, as this is a direction vector, we can simplify this by taking out a multiple. So minus 36. The common factor for the high HCF of 48, for example, uh, would be 12, right? 12 of minus, and then as a vector, this would be minus 3, 4, 3, right? Okay. So therefore, the perpendicular vector is minus 3, 4, and 3. And actually now we found 2. So then to find the direction vector of L1, again, we're going to do another one. And it's a cross product of these two things here. Okay, so we're going to do that here. Direction of line then is going to be the perpendicular vector of I, j, k of 2, 3, 2. And minus 3, 4, 3. And that's going to be I of 3, 4, 2, 3 minus j of. So obviously to reiterate, ijk of the vector notation. Okay, just to clarify. 3, 4, 2, 3. J would be determinant of 2 minus 3, 2, 3 plus k of 2 minus 3, 3, 4. And that's quickly I of 9 minus 8, that would be 1. Minus j of 6. 6 plus 6, that'd be 12. Hopefully my mental maths is there, right? Plus k of 8 plus 9, which would be 17. So that'd be 1 minus 12 and 17, I believe. Okay, and that's the direction. So now we just need a point. So a point here plus k, so a multiple of 1 minus 12 and 17. So this is the intersection, the vector, the line intersection between pi 1 and pi 2. But as we discussed, we should know a point on, we should know the a point already, right? That is on this vector line of intersection. Okay, because pi 2 contains all of L1, and L1 intersects with pi 1. So therefore, by extension, pi 1 and pi 2 have an intersection point here, right? Which was minus 7, 2 minus 7 in part A. So actually, this is the vector equation line of minus 7, 2 minus 7. And that should be vector equation. Let me check that. Obviously, that was only 2 marks. But I do think that's probably the most intuitive way to do it. Well, the one that screams to me anyway. But I do really recommend that that cross product method. I do really recommend learning that specific topic. I cannot find my phone anyway. Oh, it's here. I said I can't find my phone, but I'm literally using it to watch the chat. Hopefully that's right. There's a lot of arithmetic there. But let me check the answer to that to make sure I'm not selling anything wrong here. Uh, do, 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 do. Oh, hang on. Normal to pi 2. Minus 343. 2, 3, minus. Oh, negatives again. Bloody negatives. It's meant to be a minus 2 there. Oh, my lord. Okay, what does that simplify to? That'd be 9 is there. Okay, so what does this simplify to? Uh, so the mod scheme got that point. Okay, so I've got everything right up to here. So it's just a minus issue. I misread a minus. I swear that's the only way I'm making mistakes so far. Okay. Anyway, so 3 times 3 is 9. Uh, add 8, because obviously minus the product here. So 9 add 8 would be 17 again. And then j would be 2 times 6. Minus 6 is 0. So you're left with 17, 0, 17. And as that is a direction vector, we can take scalar multiples. So we can say it's 1, 0, 1. For instance, and so uh, therefore, the actual equation, when you get it right, that's a direction vector. And yeah, so that's the marks. Yeah, there we go. Got it right after we adjusted the negative side. Bloody hell. Got all the complicated maths bit and I couldn't get the damn sign right. Okay, yeah, so that's right. So that's the they do tend to, I've noticed in recent years, they do tend to like asking you to find a vector equation of a line that intersects two planes. Okay, exactly like this. And that methodology will be the same exact time. It might take a bit more time. But again, if you're quite adept with if you just practice the cross product and you're adept with computing determinants, that shouldn't be that long. Yeah, really, all I did here was two cross product, two determinants, right? And really, they're really easy determinants as well because IJK is on the top, so really it's just two rows of numbers here. So it's not the worst in the world, but that's the sort of method I would go for that sort of question. Okay, hopefully that's sort of clear. So to reiterate again, to summarize, because it's quite a hard vector question. So a vector equation between on the line between that line that intersects both planes. So the line has to be contained in both the lines, both the planes. So that means the line has to be perpendicular to both the perpendicular vectors of each plane. So the perpendicular of pi 1 is 2, 3, minus 2. And pi 2, we have to find that because we know these two lines are on pi 2. So the perpendicular of pi 2 would be perpendicular to the direction of both these lines. So then we use the cross product to find the perpendicular of both the directions. And that's the perpendicular of pi 2. And then we know the two perpendicular vectors. We can use it again to work out the direction vector of the line on both these planes by finding the perpendicular of these two perpendiculars. And the point, well, we know the point in part A is in both pi 1 and pi 2, so that's the equation of the line. Okay, oh boy, part D then. So then it says, given the so we're given another plane now. We're given that these planes form a sheaf. So that means where you should know, for example, in the matrix chapter, when three planes form a sheaf, that they infinitely many solutions, and that means geometrically that they all intersect at a line. But actually, we know in part C, we already know there is a line of intersection pi 1 and pi 2. So by extension, the line of intersection this line in part C has to be in pi 3 as well. So I think because we found the vector equation in part C, we can kind of substitute some stuff in to find the expressions in pi 3. Okay, and let's do that here with another document. Okay, so this is part D. So we know from part C that R is, what was it? 7, no, -7 to -7 plus K lots of 1, 0, 1, right? And that's the line that intersects both pi 1 and pi 2. Because that's the only line, as it seems, that intersects pi 1 and pi 2, because it says the line, so there's only one line here of intersection, and because it forms a sheaf with another plane, that means it still forms a line. That means pi 3, this line here has to be in pi 3 as well. So they intersect, all three of them, at the same line that we found in part C. Okay. So actually, we also know pi 3 has this equation, r dot 11a equals b. Uh, 11a equals b, right? Okay, I know b's not a vector, it's just a constant. Okay, well actually, okay, so this line has to be in pi 3 here. Okay, so again, let's think about it. Again, we can kind of apply the same sort of reasoning in part C. So, um, this line again has to be contained in pi 3. Okay, so again, the normal to pi 3 has to be perpendicular to the direction vector of this line that we found. So actually, I think if you remember, if you dot two perpendicular vectors together, you get 0, right? So if you have n1 dotted with n2, you should get 0, right? So, yes, and this is the perpendicular vector of pi 3. So I think 11a dotted with 101 have to give 0, and therefore 1 plus a is 0, which means a has to be -1. Okay, uh, cool. So now we just need to find b. So now we can complete our equation. So r dot 11 minus 1 is b. Let's think about what else we can do. Uh, I guess an instinct maybe to somehow substitute this in. Uh, but obviously that'll give us k in terms of b. That's not really helpful. Hmm. Well, do we know a point that has to be on pi 3? I think we do. Because like I said, uh, this same line has to be in in pi 3, right? This same line. So this line here, I guess we can, I don't know what we call it. This line here has to be r here. It's contained in pi 3, okay? Because it intersected the line. So it's contained in pi 3. So that means any point on this line has to be on pi 3. So I think we can substitute any given point, and actually we know this point lies again on the vector line. So this will lie on pi 3. So I think if we set r to be a known point, -7 on the line, it also has to be in pi 3 because all the line is contained in pi 3. Okay, so therefore, let's do the dot product then. So -7 to -7 dotted with 1, 1 minus y, oh, minus b. Where's that come from? -1 has to be -7 times 1, 2 times 1 plus 2 plus 7, which is 2. And that, I reckon, has to be b. And yeah, so that was the question, right? To find a and b, was it? Was that the question? Yeah, find the right values IB. There we go. Check the mark scheme was right. Just checked it now. Lovely jubbly. So that's how you tackle this question. The way I would approach it anyway. Part C. Part C is a bit different probably, but I do recommend that method. What did Part C do instead of the cross products? So they consider the line joining the mirror points. Why did they do that? Oh, yeah, of course. Because that line would be perpendicular to the plane, but why would that help? Nah, I don't like that method. Doesn't seem intuitive to me. Anyway, so yeah, so that's that vectors question dealt with. So hopefully it made sense. So again, to reiterate what we did with part D, uh, so we found the vector equation of the line that is contained in pi 1 and pi 2 when they intersect in the line. Now, pi 3 intersects to form a sheaf. So a sheaf means geometrically intersect at a line as a line in a line, right? All three planes. Now, pi 1 and pi 2 already only intersect at this line here. So that means pi 3 also has to intersect at this line that we found in part C, which means this line has to be contained in pi 3. Okay. So then what we said was, well, the normal vector to pi 3 has to be perpendicular to the direction vector of r, this line here, because this line is parallel to the plane, so it's going to be perpendicular to the normal vector. So then what we did was dot the direction vector with the normal vector here, and then we solved for a. Okay, and then we found, because every point on R on the line has to be in pi 3, because pi 3 contains the whole line. Then we just found any given line on the line, which was here, clearly, this point here. And then we substitute it in for R here, and then we found B. So hopefully that's clear. But that's that question dealt with. Okay. But yeah, I guess if there's any questions, I'll try my best to help. But yeah, as I said, I do apologise. I missed the earlier questions. Hopefully, I've addressed them now, though. Okay, but I'm going to move on then quite swiftly. Okay. Oh, you go differential equation. Okay. Water's flowed in and out of a large tank. So it's giving us information here essentially. Uh, Given that T0, the volume of the water tank is decreasing. Right. Well, I'm going to be completely blunt. I'm not the best at these formulating modeling differential equation questions. So what I think a good exam strategy is, I'm going to leave that till the end. Okay. So I'm going to do part B here. And then if I have enough time, or because I'm probably going to might maybe struggle a little bit, but oh, or I don't know. but I'll arrive to that at a later point. But we'll see. Um, I guess it's quite similar to. I don't know. I'm gonna leave it there. I will do part B first. So then it says the derivative of arctan e to the 0.4t. Let's write that down here. Of e to the 0.4t. So it's a chain rule question, right? So we need to find the differential of so if we let so say if we let u equal e to the 0.4t, therefore y, I guess you could say, is arctan arctan of u. Therefore dy by dt, well, that's going to be the derivative of dy du, so the derivative of arctan times by dt. This is easy to compute. So d by dt is 0.4 e to the 0.4t. That should be quite routine from normal maths. But this is where the further maths bit is in. So we need to differentiate arctan. If I'm not, this, they might give you this in the formula book actually. Let's check the derivative section. Oh wow, they do here. There we go. They do it all for you. Arctan is 1 over 1 plus x squared, the derivative. To dy du. So 1 over 1 plus, instead of x squared, it's u squared. Okay. Obviously, I'm breaking this down a little bit using chain rule because it might be a bit of a weird looking function, but you might be able to do it really quickly in one step. But there we are. So let's combine it together. 1 over 1 plus u squared. Now u is e to the 0.4t, so let's substitute that in. So that's e to the 0.4t squared times by 0.4 e to the 0.4t. Cool. That's going to be 0.4. Now, actually, the e to the 0.4t will cancel one of these. So you just be left with 0.4 over 1 plus e to the 0.4t. If I don't slap my writing. Cool. So hopefully, simple 2 marker. Let's have a look at the next part of the question. And they didn't ask us that for no reason, so we're probably going to need that in another question if we bear that in mind. So then it says solving the differential equation part A. Determine an equation for the so we need to solve differential equation, right? Okay. So might do some stuff here to simplify it first, but because we have dv dt plus k lots of v plus a function of t, this is going to be, we won't be able to separate this by separation variables, so we're going to need to integrate in factor. Okay, so let's rearrange this then. So we're going to have dv by dt plus 0.4v and that's going to equal 3 minus 4 over 1 plus e to the 0.8t. Okay. So, integrating factors. So when you've written it in this form, so the dv/dt is on its side with no number in the front or function. The integrating factor will be e to the integral of 0.4 dt, right? So the integrating factor is the integral of this function of t, which is just 0.4 in this case. This integrating factor, so we integrate this, e to the integral of this, which would be e to the 0.4t. We don't need to bother with plus c, that's okay. Cool. Yes. So then what we can do is we can times each part by e to the 0.4t, every single part of the equation. So I'm going to do that here. E to the 0.4t dv by dt plus 0.4 e to the 0.4t v, was it? Uh, yes, equals 3. All of this, 3 minus 4, 1 plus e to the 0.8t, e to the 0.4t. Okay, so why do we do it in this? Well, actually, um, we can now integrate both sides, because if you notice, and again, if you use integrate, I haven't done this in absolutely ages, in years, but if you notice, this is actually the product rule of differentiation in disguise. So this is the same as saying differentiate with respect to t of v e to the 0.4t, right? Because then that would be dv by dt of e to the 0.4v t plus the differential, which would be zero point 0.4 e to the 0.4t v. And actually, that's what we've got here on the left-hand side. You can double check this, because if this is true, then you've done the integrating factor method right. So this is a product rule in disguise. So therefore, what we could say is the integral. So then we can integrate both sides. So we can say the integral of respect to t of ve to the 0.4t dt is the integral of this right-hand side. So e to the 0.4t, 3e to the 0.4t, let's times it out, minus 4 over 4e to the 0.4t over 1 plus e to the 0.8t dt. Okay. I mean, actually, a derivative with respect to t integrated, well, that's going to be the same function. So it's going to be ve to the 0.4t, and then we need to integrate this. So how do you integrate something like this? Let's separate it. So integral 3e to the 0.4t. Well, instead of times it by 0.4, we're going to divide by 0.4. So what's 3 divided by 0.4? That is 15 over 2 e to the 0.4t. And then this bit. Now this bit, I reckon we're going to need part B here. Okay. Well, does this not look vaguely familiar? No. No, that's no. I did the cardinal sin there. I didn't realise there's a 1 here. Now I did a very naughty thing there. So that's what you timed it by. I cancelled the e to the 0. No, you can't do that because you're adding 1. For some reason, I thought you were times in. Yeah, I forgot there's a 1, but I can't read my handwriting. So that's just 0 0.4 e to the 0.4t over e to the 0.4t squared. That's e to the 0.8t. Okay. And I could see I went wrong there because obviously I need part B, and it should look similar to this, but it didn't. Okay. Cool. So hopefully, yes, that's part B corrected. So 0.4e 1 plus e to the 0.8t. That's e to the 0.4t squared. You realise that because you add in 0.4t, add 0.4t to get 0.8t. Cool. Well, actually, then, because of that, notice how this is exactly the same as part B, just with a constant. So, we could say that's if we say that's 4e to the 0.4t over 1 plus 8e to the 0.8t, we're going to have to times by what? So we need to keep it 0. So it's going to be 0.1, isn't it? Because then if we did 4 times 0.1, that'd be 0.4. And why did I do this? Well, I'm making it very explicit that now this part is exactly the same as the integral here. Now, we want to integrate this. Well, actually, if we differentiated arctan of e to the 0.4t, it differentiates uh, to this result here. But then if we go backwards, this will give the integral of this. No? Okay. And so we can literally, we know this is going to be some lots of arctan as a result of e to the 0.4t. Because the differential of arctan of e to the 0.4t here gives us this. So if we integrate this result, it's going to give us some lots of this. Now, this is 0.1 lots of this. So we're going to need to times by 10 here, because then if we times by 10, this will cancel the 0.1 to give us exactly this. To give us exactly the integral. So we are going to need to say, instead of arctan, it's going to be 10 arctan. Okay. Because then multiply by 10 again, integrate this. If we integrate this, we get arctan. So we're going to need to times by 10 of either side to get the integral. This is 10 arctan. Okay, hopefully it made sense. So we're just using part B there. And actually, and then we also need a plus C. Also to explain vaguely here, why we didn't add a plus C for the integrating factor. It's because we're gonna need to integrate elsewhere, so it wouldn't really matter. But that's how we do it anyway. So we add the plus C here. Okay. Okay. So we're left with here. So this is the equation we have. If you did integrate, if you practice this, hopefully this should be second nature by now. It's a fairly standard integrating factor question. Obviously, with a weird integral here, but if you look at part B, hopefully it should throw you off too much. Okay, so now we need, because it's a differential equation, we need V on its own in terms of T. So the way we're going to do this is we're going to divide by e to the 0.4t. So V then on its own is going to be, and by and mind, you can divide by e to 0.4t because you will not get 0 here. E to the anything will never ever be 0 because if you look at the graph, it tends to 0, but it never be 0. So you are allowed to do that, okay? There's no like solutions, there's nothing to worry about can you do this or that. That's completely fine in this instance. So 15 over 2. Now, e to the 0.4t divided by itself, it's just itself. So 15 over 2 minus 10 tan of e to the 0.4t. Well, there's nothing we can really do there. We just divide by e to the 0.4t. Or we could say e to the minus 0.4t plus c over e to the 0.4t. And I reckon that's the equation. Obviously, you have plus c, but they also give us some information to find c, to find a particular solution. Um, well, it says initially the tank contains 10 litres of water. So I think T is 0, V is 10. Double check that V actually means 10. So there are V litres in the tank at time minutes. Yes, so there are 10 litres in the tank. And initially it meant T is 0. So that's our boundary condition, right? That's our condition to find the particular solution to find C. Okay. So that T0, that means V is 10. Therefore, 10, substitute that in, has to be 15 over 2 minus, well, 10 arctan. Well, e to the 0 is going to be 1 over 1. E to the 0 is 1 again. Plus C over 1, so it's going to be just plus C. Well, let's do some stuff with the calculator. Well, 10 knots of arctan 1, tan inverse, is hang on, 5 pi over 2. So 10 is 15 over 2 minus 5 over 2 pi. So 5 pi over 2. Cool. And that'd be plus C. Therefore, C is let's move F to the left. So 10 minus 15 over 2. That would be 5 over 2. Add 5 over 2. So it's going to be 5 over 2. Add 5 over 2 pi. So that's your C. So therefore, your full equation is now going to be 15 over 2 minus 10 arc. I'm going to bring this to E on the numerator. So I'm going to say e to the minus 0.4t. 10, sorry. 10e arc tan of e to the 0.4t plus c. So it's going to be plus 5 over 2 plus 5 over 2 pi. Cool. Okay, there's a lot of stuff going on there. So it's 7.5, which is this, minus 10e to the minus 0. Arctan of this, yep. Plus 5 over 2 pi plus 1. And this is times by, that's times by e to the minus. Oh, yeah, because c here is divided by 0.4. So that's over e to the 0.4t. There we go, lovely jubbly. There we go. So that's part C. That's the bulk. That's the bulky part done. A bit fiddly, but hopefully that should be fairly standard if you practice for 6 marks. There we go, lovely. If you solve with integrating factor, that's the sort of approach you want to take. Okay. But then it tells us this. So after 10 minutes, the volume of water was 8. So T is 10, volume is 8. Evaluate the model notes of information. So this is fairly typical, and it's fairly nice because they give us this information for a reason. I think they want us to substitute to see how close the answer is to the real life situation. So I think what happens if we substitute T is 10? Do we get close to 8? Let's have a try. So sub T is 10 into V. So that means V is 15 over 2 minus 10 e to the minus 0.4 of 10 arctan e to the 0.4 of 10 plus 5 over 2 plus 5 over 2 pi divided by e to the 0.4 of 10. There's a lot of stuff there, but let's plug all of that into the calculator. And the result you get, if I plug this all in, tan inverse of E 0.410 plus, oh man, there's a lot of stuff going on here. 5 over 2 plus 5 over 2 pi of e to the 0.4 of 10. Okay, so you get apparently that this is 7.405 something. This is 7.4 to nearest decimal place. Okay, but it said actually the volume was 8. This is a really tricky one. I did plug it all in right. Let me have a check. Yeah, okay, this is a very okay. They're quite nasty for this because you can be pedantic and say, well, it's not too as it's not like it's not far away. Like you don't get a negative value. You don't get like a million. You don't get like 2. 7.4 isn't leaps and bounds away from 8, but is it still accurate enough? I'd honestly argue no. I'd say if you round it's the nearest decimal place, if it's not 8, then it's not accurate. You kind of have to use your own judgment with this sort of thing. I would say no. I think the mark scheme would allow either way, but I'd say no. Uh, ah, uh, uh, I'm gonna say no. And you know, if I lose a mark, well, I'll still sleep easy. Okay, no, but I'll say no because uh, model predicts is 7.4 uh volume is 7.4 t equals 10, okay, which is not which is not rounded, which does not round to 8, sorry, I should say. And you can see this because obviously that would be 7, not 8. So is not a close enough estimate to the true value. So I would say something like that. You could say perhaps not close enough estimate or not an accurate enough estimate, I guess, if you want to be a bit scientific. But that's the gist. Yeah, so it says 7.4 litres, so the model is not very accurate as it predicts approximately 7.5%. Who's calculating the percentage? Come on, man. Below the actual level. Okay. Uh, I don't know. That's my explanation. What does they say for part D? Again, we'll look at part A if we have enough time at the end, but oh wow. Evaluates F, makes it says make an appropriate comment, so you don't have to calculate the percentage error or something. For evaluation, yeah, they give you a lot of leeway for part one. For part D, sorry. But yeah, I'll come to part A in a minute because I think it's very important. I've heard about these two questions, and I think a lot of people. Let me keep an eye on the chat. Actually, any questions? Does it look it? Okay. Chat looks fine for now. But yeah, these two questions I think are beast from what I've heard. So question 7 over here. Well, we don't need 7 because it's A. Okay. So explain why this holds for any function f of r. Okay, there's quite a lot going on here. So I'm going to write this down. R is 1 of 2n minus 1 to the r. F of r equals the sum of between n and r equals 1. F of 2 to the r minus f of 2 to the r minus 1. So, no, not 2 to the r, 2r. There we go. Now, actually, what this is screaming to me is actually we're going to need to consider odd and even numbers for two reasons. First of all, originally it's 2n, then it goes to n. That implies we're somehow splitting this up in two. So in even and odd, perhaps. But also, notice 2r and 2r minus 1 are even and odd numbers. So I think this is a strong hint that we're going to need to consider odd and even. Okay. Uh, Again, like I say with normal maths, if you have an unseen or a function or a sum, sorry, that you're not particularly aware of what to do, try and work out the first few terms. Uh, so that's going to be well, it's going to be minus 1 to the r, which is 1. That would be minus f of 1. Okay. And then when r is 2, minus 1 squared, that would be positive. So it can be plus f of 2. And then minus 1 cubed is going to be minus again, minus f of 3. And then to the 4 is going to be a positive of 4. And hopefully you start to notice what's happening here. We have the evens have a positive result, and then odds have a negative, which is actually what is going on here. So we've kind of got a lot of it now. So I guess the last thing we need to piece together is how do we get from 2n to n? Well, actually, it kind of helps us here again because it's 2r. So let's say we can write this as minus f of, I don't want to say this. No, sorry, let's do it. So let's group this all together, right? Let's group the odds together. Minus f of 1 plus f of 3 plus f of 5. Now, what would be the final result? Okay, the end point is 2n. Now, 2n will give us an even number. So it's going to be 2n, or 2n minus 1. It will be the final odd number in this summation. And then we're going to add the evens, so f of 2 plus f of 4 plus dot dot dot. And then plus the last odd number, even number, will be 2n. Okay. Because obviously multiple of 2 has to be even. So hopefully that makes sense so far. And actually that's a lot of the battle done. So how can we write this? Well, note that every odd number can be written as 2k minus 1. Okay. Which is what's going on here. So 2r minus 1, 2k minus 1. Well, and then obviously k0. Does it start from 0? Does it? No, it starts from 1. Okay. Uh, okay. Okay, I get what the question's asking. I just don't know how to formulate the explanation. Let's look at it a bit more. Hopefully that should be clear. So what we could perhaps say is this is equal to minus of and even number 2k. Therefore, this sum uh, is equal. Therefore, we can say the sum is equal to minus again f of 1. We're going to rewrite it like this. So we're going to say f of 2 of 1 minus 1. Oh, yes, so k is 1. Okay, so k is 1. That will give us 2 times minus 1, which is 1. Okay, so 2 of 1 minus 1 is the same of f of 1. Then the next number would be f of 2 of 3 minus 1 plus f of 2 of, no, sorry, 2 minus 1, sorry. 2 of 3 minus 1. And no, hopefully you notice the pattern that's going on here. So we rewriting, we put in every odd number in this form. So then we're plugging in k 1, 2, and 3 to give us the odd numbers 1, 3, and 5. And it's going to continue this pattern. And then the final point, if we remember, is 2n minus 1 up here, right? Now, this is in the same form, so it's going to be 2 of n minus 1. So really, this is sort of saying a summing from 1 to n. So that's how we get from 2n to 1, to just n. So that's the odd number. So what about the even one? So then plus f of 2 of 1, because remember it was 2, f of 2, then f of 4. If we can write it in 2k now, we plug in again k 1, 2, 3, to get the even numbers right, 2, 4, 6. Hopefully you should remember that from GCSE actually. So that's f of 2 of 1, and then f of 2 of 2, plus f of 2 of 3, and then it will continue the same pattern. And then the last point in the even series is 2n, and so that's f of 2 of n. Okay. Um. Well, actually, we can kind of then formulate, bring back the sigma notation. So is this not the sum of the minus of the sum of f of 2 of r? So r is the one here that we're plugging in each time, minus 1 between r is 1 here to the end point n. Likewise, then that's the odd series. What about the even series? So then that's going to be, again, it looks like f of 2r, right? So 2, and then we're plugging in r is 1, then 2 and 3. And that's going to, again, between r is 1, not, oh God, what's that? R is 1, to r is n. So n here, so that's the end point. Well, actually, if they have the same end and start points, we can combine the series together. So we can say r is 1 to n, and then we can we put the minus inside here, absorb it into here, and then we can say f of 2r minus f of 2r minus 1. Is this now not the formula that asked us to prove? It is exactly the same. So actually there, for 2 marks, we've shown it. So that's your explanation. It doesn't necessarily have to be in words, again, as long as you clearly break it down like this. But yeah, that's the explanation. I think that's the one that threw people off. Perhaps they might have knew how to do it, what was going on, but they didn't know how to break it down to show clearly that this is how you convert from this one to that. But yeah, I guess the key takeaway with this is to recognise you're dealing with odd and even numbers, right? That should scream to you that this is odd and even, and you're halving n, so you kind of have to split between odd and even. That's how and also, like I said, if you write the first few terms, it should become quite apparent what the series should look like. So we went from there. Hopefully it made sense. Okay, so that's part A. So then part B, so use the standard summation formulae to show that this is true. Okay, so again, let's write the series. That's between r is 1 and 2n of, what was it? What was the, in the sum? R of minus 1 to the r, minus 1 to the r, plus 2r squared. Okay. Actually, that looks a bit, let me make that a bit more clearer. Plus 2r all squared. Okay. So obviously this looks very similar to the formula in part A. That they didn't ask us to do part A for no reason. Um, so we're going to need to use part A here. Um, hmm. But let's have a look then. Let's compare. So, it's not very. So obviously we have -1 to the r times by a function, but here -1 is kind of wrapped inside. It's not very clear what function we're multiplying by. I think the best procedure here is to maybe expand and see what happens. So let's do that here. So -1 to the r plus 2r of -1 to the r plus 2r. Just squaring it. Uh, well, that's going to be. I didn't write that very nicely, did I? -1 to the r. Tell you what I'm going to do. I'm going to use square brackets to show clearly. So of -1 to the r plus 2r times by -1 to the oh god -1 to the r plus 2r, and then we're going to times it out. So -1 to the r times -1 to the r. So that would be -1 r plus r, which is 2r, and then -1 to the r of 2r times by another -1 to the r 2r. So that's going to be 2 lots of -1 to the r of 2r. Okay. Uh, plus 4r squared. Okay. Now, this negative is causing quite a stir, isn't it? Well, actually, notice how if you use index laws, we can say that -1 to the 2r is the same as -1 to the r all squared. No, sorry, squared, the other way around, squared r. But -1 squared is just 1. And then you're left with 1 to the r, which is just 1. So this is simply 1. Uh, hang on, what have I done here? Even I can't see what I've done here. Is this meant to be a plus here? I think it is. Plus 2 lots of 2r, lots of -1 to the r, times 2, because there's 2 lots of them. Okay, yeah. Okay, let's deal with this bit then. Plus -1 to the r, 2 times 2r, which is 4r, plus 4r squared. Okay, so that's this bit dealt with. Now we're going to times it by r. So this integral, this bit here, is going to be times all of this by r because we expanded the bracket. So that's going to be r plus r of -1 to the r, 4r, sorry. That's going to be 4r squared, isn't it? 4r squared -1 to the r plus a 4r cubed. Okay. So I'm gonna okay. So that I'm gonna write that down. So we get to this point here of 2n of r is 1. We got to the point r plus 4r squared of -1 to the r plus 4r cubed. Okay. That's by simply expanding, like we just did, expanding this whole bit, this bracket, with some index laws, and that's what we got. That's where we got to. Okay. Like, cool. Now, we can split each part up separately as its whole different sum. So that's 2r of r, 2n lots of r, plus 4 lots of the sum of 2n to r is 1, -1 to the r for r squared. We can bring the 4 out here, and then we're just left with r squared of -1 to the r. I've written it in this particular way, and I'll show you why in a minute. Plus the sum of sum of r is 1 to 2n of 4 lots of r cubed. Now, actually, we know how to compute r and r cubed, don't we? You should remember the formula of r to n of r is 1 That's going to be half n, n plus 1. Likewise, the sum of n of r is 1, r cubed, remind me, is a quarter n squared, n plus 1 squared. That should be in the formula book, I believe. Let's check. Here we are. Yeah, r cubed. Yeah, there we are. Lovely. Okay, so actually, if we just substitute n for 2n, we can work out the first and the third sum. But what about this second sum here? Let's write this down. 2n of r is 1 of minus 1 to the r squared. But this looks fairly similar to what we did in part A, does it not? Part A says minus 1 to the r times by a function of r by 1 and 2n. That is this, f of 2r minus f of 2r minus 1. Well, let's make this very explicitly clear. Minus the function is r squared, no? Minus 1 to the r times f of r is, well, f we times by r squared, so this has to be a function here. Now, let's use our part A, which is between n and r minus 1 of f of 2r. So f of 2r is going to be 2r squared minus 2r, no, f of 2r minus 1 minus, that's what we've got to work out. F of 2r is 2r all squared. To make that clear, 2r all squared. Hopefully that's clear because f of r is r squared. So then substitute 2r for r. There we are. Then 2r minus 1, substituting that for r. It's going to be 2r minus 1 all squared. Okay, and now this is another gnarly expansion. So now we need to work with this sum here. Okay, a lot of work with this. So 2r squared, that's going to be 4r squared minus this expansion here. So it could be 4r squared again. Actually, let's do the expansion first. Let's not overcomplicate ourselves. So minus the sum of, let's expand this. So the expansion of 2r all squared is this. Hopefully you can see that. And then this expanded is 4r squared minus 4r plus 1. Okay, and then this simplifies. So n of r is 1. 4r squared minus 4r squared, they cancel. That'd be left with 4r minus 1. Okay. And therefore that's going to be 4 lots of n of r is 1 of r minus between n and r is 1 of 1. Okay, so now let's bring this all together then. So now we've worked out the second sum. This is the second sum. We've worked it all out. Boy, that's a lot of work. So sum, if you remember then, is between 2n r is 1 of r, was it? So look here again, of r plus 4 lots of 2n and 1 of minus 1 up. Well, we've already said that this whole sum here is this bit here. So we're going to need to times all this by 4. So it's going to be 16 lots of n is r between n and 1 of r minus 4 lots of n and r is 1 is 1. Okay. And then we have plus 4 lots of between 2n and 1 r cubed. Okay, now we can use a standard summation. So it's just really at this point a substitution and algebra exercise. So we know that sum of n to r is this, half n. So in place of n, we just substitute 2n. So it's going to be half of 2n plus 1 plus 16 lots of r, which is going to be half n plus 1. Double check that, yeah. Because now, obviously, this is n, not 2n, so we just keep it as it is, n minus 4n. Because we're substituting, this is saying we're adding 1 n times, so this is simply n times by minus 4n, plus 4 of r cubed. Now, r cubed is a fourth of n squared, n plus 1 squared, so substitute 2n for that, so a quarter of 2n squared, 2n plus 1 all squared, right? Substitute it at 2n into here. So a quarter of 2n squared, 2n plus 1 squared. Okay, now we just simplify this bit. So that'll be n of 2n plus 1 plus 16 over 6, which is 8 over 3 of n plus 1 minus 4n plus 4 of a quarter, they cancel, so you're left with 4n squared of this, so 2n plus 1 squared. Okay, what form does it want us into? Maybe we don't need to do all this expanding. What form does it want us to give it in? Let's have a check. Okay, it has to be factorised in this form. Okay. But what I notice is n and 2n plus 1 has to be factored out with a quadratic. So I need to look for n and 2n plus 1 as common factors. So I need to bear that in mind. But this is going to be tricky. So we are going to have to expand and simplify, I think. Actually, no. N is in all of it, right? So it's going to be 2n plus 1. N is common to every term here. So we're going to need 2n plus 1 plus 8 over 3 n plus 1 minus 4 plus 4n of 2n plus 1 squared. Okay, but we also need a factor of 2n plus 1. Now we get 2n plus 1 from there and from here. So that implies we can get a factor of 2n plus 1 from here, but it's not apparently clear we can do that. Let me just check my working then. Where did the 6 come from, actually? Where did that come from? Let me check that. 16 of r, that's a half. Where did it get 6 from? Eh? I must have misread a number. I don't know. There's a half. Anyway, that's a half, not a 6. So actually, this whole bit simplifies to 8, not 8 over 3. I don't know where that came from. So that might make our life a bit easier here. So 8n plus 1. Okay. So we need so the question is we need to get it in the form of n of 2n plus 1 with a quadratic. Okay. But so that means we need to factor out a 2n plus 1 to from this bracket. So 2n plus 1 is in these two terms. So we need to get a 2n from here as well. If we can do that, then 2n plus 1 is common to every term, and we can factor it out. So let's leave 2n plus 1 there. And then let's expand this. So that might help. 8n plus 8 minus 4 plus 4n of 2n plus 1 squared. Okay. Now that goes to n of 2n plus 1. Now 8n plus 8 minus 4 is 8n minus 4. And that's great news. Okay. Because why? This is a factor of 2n plus 1. Because then we could say 2n plus 1 of the bracket 1. Now, 8n minus 4, observe, is 4 lots of 2n, hang on, no, 2n plus 1. 8 minus 4 is plus 4, there we are. 8n plus 4 is 4 lots of 2n plus 1. So life is good. So now we have 1 plus 4 plus 4n. We take one factor out, so we just left with 2n plus 1. This will then give us a quadratic. So lovely, lovely, lovely. That shows it in the right way. So then we're gonna just add this, do this whole bit up. So we're gonna 1 over 4 is 5 plus 4n times 2n plus 1. That's gonna be 8n squared plus 4n. And that is our quadratic, okay? Cool. So that's part B done, finally. Oh man. I don't think there's a quicker way to do that. Obviously you don't have to write all this stuff out. I'm just doing it to show clearly how to do it, to help people, to explain. But if you can spot it, then just you can just jump right to the working out. Don't need to do any like explanations or anything like that. Hopefully that helps. That's a monster question, that is. For 6 marks. Okay. Oh man. Oh, hang on. Is that right? Oh, is that the right quadratic? 8n squared plus 4n plus 5. Let's check. 8n squared plus, yes, same one. Cool. So that's all right. Cool. So then part C is evaluate this. So 50 and R is 14 of this. So this exact summation has to be between 50 and 14. Okay. I'm gonna write this again. So again, with part C, write the copy of the sum. Between R is 14 and 50, was it? Of what was it? Minus R of minus 1 to the R plus what was it? Some R squared. I can't, it doesn't really matter because we're just going to substitute our result in. Minus 1 plus 2R squared. Okay. Cool. But notice this is in the form of 2R of R is 1 of R of minus 1 to the R plus 2R squared. But it's not apparently clear at the moment, but I'll see why. You should notice that if we are not starting from 1, we can make it start at 1. Because we can split this up to say this is between 50 and R is 1 of this whole expression here. Minus between R is 1 and 13 of R. I don't think it starts at 50, does it? Is it like 50? What number is it? Is it 50? Yeah, 50. Okay. Between 13 and R is 1 of the same, right? I'm going to need extra paper here to do my working. Minus 1 to the R plus 2R squared. Okay. You can kind of visualize this because kind of think of a number line, right? We're actually starting at 14 and we want 50. So we want 14 to 50. But we only know these summations starting from 1. So the key point here is 1. So how can we get this equivalent? Well, you can start from 1 to 50, subtract 1 to 13 here. And obviously this goes up in ones, so it's not a continuous thing, but it goes up in ones. So then the next one would be 14 to 50. So we get rid of any overlap, so we get exactly 14 to 50. But yeah, that's the method behind that. Oh no, so hang on, no. Eyes. No, I think it. I think it would it be 14 because it'd be divisible by two. We should make this life easier. But if it's 13, it might be a bit rough here. Pretty sure it's 13 now, isn't it? Yeah, because you want to get rid of the first 13 terms. Yeah, so you want to start at 14. So you get rid of the first 13 terms. This starts. Yeah, so that should be right. Okay. But notice it's in this form. So 2n is 50. Uh, um, uh, so actually we can apply the formula in part B. So if we substitute, if we use 2n is 50, that would imply n is 25. Therefore, the sum here, I'm going to write it in in another document. Uh, yes. Let's bring it over here. There we are. So this sum here to copy. If it loads. This sum here between r is 1 and 50. No, yeah, r is 1 and 50. Of blah 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 blah. Right, I'm not going to write it again. That weird -1 bit. That's going to be. Uh, well, that's going to be this equation that we did in part B. No, that's going to be this in part B. So our value of n, which is 25, because we're halving the upper limit of 50. So n is 25, so the double of that is 50 here. So we substitute n is 25 into here. So that's what we're going to do. So 50 of 2n plus 1, so that's going to be, no, 25, wasn't it? Not bloody, not 50, 25. That's because I'm doing 50s everywhere. Of 2n, that's going to be 50 plus 1. That's where I got 50 from. I'm working ahead. 50 plus 1, that's 51. Of 8n squared. Right, I'm going to do this. I'm going to just write 8 of 25 squared plus 4 of 25, was it? Plus 5. Put that into a calculator. And this summation would be this all big number here, 6508875 6,508,000 and 8,875. Okay, that's what you get. You put in the calculator. So that's between 50 and 1. Then we want to work out this next other sum. We're going to minus 13 and r is 1 of the same thing. Now, if we did 2n is 13, n would be a decimal. You cannot have decimals with sums like this. It has to be an integer. What I propose we do is actually splits up again to r is 1 to 12. So the lowest, the closest even number that we can divide of blah 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 blah, plus substitute 13 into the sum. So then to get the 13th term, um, it's going to be substituting 13 into here, right? So r is 13. 13 of minus 1 to the 13 plus 2 of 13 all squared. Because that comes from r of minus 1 to the r plus 2 to the r squared at r is 13. Okay, because you add in you taken away the 13th term, and we're going to add it separately, because then we can split this up into an even sum, which we can apply the formula, because that would mean 2n is 12, and therefore n is 6, which gives us a nice number to work with, which we can use into the formula. Okay, is that the right formula? R of minus 1 to the r of 13 of minus 1 to 13 plus 2 of 13 squared. Cool, so that should be right. So now we're going to apply the exact same formula again as we did in the other one. So n, well, n is 6 of this one. So that'll be 6 of 2n plus 1, which is 13. 12 plus 1 is 13. Of 8 of n squared, which is 6 squared, plus 4 of n, which is 6, plus 5. And then we're going to add this bit here. Let's work this out first. That's going to be equal to, if you put that into the calculator, 13 of minus 1, it's odd, so it'd be minus 1, plus 2 of 13, all squared. That will get you 8125. Okay, so we're going to add 8125 afterwards. So let's put that into a calculator. 6 of 13. And that gets you 32851. Therefore, the sum is this. So it's going to be 6508875, the first one, minus this sum here. And that's going to be 6508875. This number here, 6476024. And that should be the answer. Okay. Yes, that's the number the mark scheme got. Cool. So that's how you tackle that question. Very, very nasty, serious question there, I must admit. But that's the process for, wow, 12 marks. Okay. Okay, I think it is hard, especially in exam conditions. But I feel like if you really know your series and the question does guide you a bit to show you what to do. So I think once you expand this, then you can split it up into R's and R cubes and stuff like that, and you can kind of use the results. I think it then becomes like a normal series question. But it's quite tricky to actually mess with the numbers, and B, like even when you do it all, it's such an algebra grind. You are bound to make mistakes. So it is quite a tough question, and it's quite an unusual series question as well. But I'll tell you what, it's quite fun to do it. Obviously not an exam, but that's how you approach that question. Hopefully that made sense how I went through it. But yeah, wow, what a question though, eh? What a bloody question. If there are any questions, actually, again, let me know in the chat. I am trying to pay attention to it now. But hopefully that made sense. But obviously this will be re-uploaded as well on my YouTube. As well. But yeah, so we're on the final question now. Matrix modeling. I don't think this is too bad, in my opinion. I think once once you get past all the modelling, it's quite simple matrix stuff you are doing here. Okay, so let's have a look at the question. A colony of small mammals has been studied. In the study, the mammals are divided into three categories. So, newborns, juveniles, and breeders with a certain age range. State one limitation of the model regarding the division into these categories. Okay, so, well, it's kind of assuming from the word breeder that they kind of become adults and that all like breed together to form obviously newborns, which grow to juveniles, which then be mature to breeders. Um, I would probably say that the model is implicitly assuming that every single adult is a breeder, but we know infertility is a thing. So I would say the limitation is model does not factor in infertility, meaning not all adults are breeders, okay? Because that's what it's saying. Everyone over 3 months, every single mammal is a breeder, no exceptions. But that isn't really true, meaning that not all adults, which is over 3 months old, are breeders. So that would be my limitation. Okay. So then a model for the population of a colony is given by a matrix equation where A and B are constants, N, J, blah, 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 the respective numbers in each section, N months after this. So N is in months, okay. After this, at the start of the study, the colony has breeders only. So that's telling me at N is 0, J, N0 equals J0 equals 0. So initially, the number of juveniles and newborns is 0. That's what that's telling me. And then it says, according to the model, after 2 months, so N is 2, the number of newborns, so newborns is N2, big N2, is 48. The number of juveniles is 40, so J2 is 40. Then it says determine the number of mammals at the start of the study. So obviously at the start there's only breeders. So that's asking us to find B0 and then show that A is 0.8. Okay, let's use this information. So let's write down the matrix model. So what is it? N plus 1, J n plus 1, B n plus 1. This is 3 by 3 matrix of 0, 0, 2, AB0, and 0, 0.48, and 0.96. And that's between NN, JN, and BN. Okay. Okay. Um. Oh God, let's go back. I think what we can do is essentially start from n is 0 and then work our way to n is 2. That's not far away, right? From n is 0 to n is 2. And we can use these initial values to help us. So I think we can first say, let's summarize the information down first of all. So it's told us that when n is 0, big N 0 is J0 equals 0, right? And so therefore B0 we do not know. But the only amount of total amount of mammals in year 0 at the start is just B0. There are only breeders there. Well, and then until the N is 2, that N2 after month 2, the number of newborns N2 is 48, and the number of juveniles is 40. And again, we don't know anything about breeders. So I think we can use this model to kind of work our way to month 2. So let's say that N1, and there's a lot of zeros here, so I think we get some nice cancellation. So N1, J1, and B1, that's going to be 0, 0, 2, A, B, 0, 0, 0.48, 0.96. Of N0, which is 0, J0, which is 0, B0, which we do not know. Okay. And that's the main idea with these matrix modeling questions. Don't get thrown off. I don't think they're as bad as people make it out to be. I think they're just really thrown off by the fact there's such a modeling question in matrices. And I will say that it's the textbook's fault because there's not any questions like this in the textbook. But this is why I'm going over it now to kind of explain this sort of step. So this is with matrix multiplication, right? So to get the first row, that's 0 again. So that's going to be N1 is 0 times 0, 0, 2 times B1, so that's 2B0. Which I guess makes sense because the breeders are going to form newborns in the next month, I guess. Anyway, and then for J1, that's going to be A times 0, B times 0, 0 to 0, so that's 0. And then B1 is going to be 0, 0.48 times 0, 0.96 B0, which I guess, again, makes sense because you're going to lose some breeders due to old age, right? They're going to die out, essentially, bleak as it is. And then, likewise, we can do N2, J2, B2, because these are N1, J1, B1. By the same, we can reuse the model. So A, B, 0, 0, 0.48, 0.96 of J1, N1, which is 2B0, J1, which is 0, and 0.96B0. Okay. And we can actually, yeah, so let's do this matrix multiplication. So 0 times 2B, that's 0, 0. 2 times 0.96 is 1.92. So 1.92 B0. For the next row, A type, so that's 2A B0 plus B plus that's just 0. So in the end, it's just 2A B0 for the second entry. 2A. Yeah, cool. And then for the third row, B2, 0 times 2B, that's 0. 0.48 times 0. 0.96 times 0.96 B0 is 0.9216 B0. Cool. Now, actually, we know information about N2 and J2. So N2 is 48. So that means 48 is 1.92 B0. Well, that's just want to know. So therefore, we know that B0, the initial amount of breeders, is 48 divided by 1.92, which is 25 exactly. Cool. We also know that J2 is 40. So therefore, 40 is 29B0, which doesn't help, I guess. Hang on. Oh, hang on. Hang on. Does that make sense? Not sure it does. Hang on. No, it's 2AB0. Again, I thought it said 29. That's why. Bloody hell. 2A. So 40 is 2A of 25 because it's B0. So we're reading the second row. So J2, which is equal to this, 40 is 2AB0. Cool. Therefore, A is 40 divided by 50, which is 0.8. Did it not tell us to show that A is 0.8? It did, so we got that right. So then to say part I, the number of mammals that start the study Well, it said there are only breeders, so this is therefore number of mammals at start of study, which is 25. Because remember, it said there were no juveniles or newborns, only breeders. So B0 has to be the initial amount of breeders, which therefore has to be the total number of mammals at the start. Okay. So that's what all of part B does. So that's I and then II. So then let's have a look at part C. Really nice so far, in my opinion. Nothing too much to be freaked out about. Just using the model to some fairly simple matrix multiplication. So it says in terms, determine in terms of B the inverse. Okay, so we have to invert a 3 by 3 matrix. Lovely, lovely. Okay, let's write that down. Was it 0, 0? What was it? Remind me of the matrix. It'd be this, right? 0, 0, 2, and then A, which is 0.8. B, was it 0 again? 0, 0, 0.48, 0.96, and then we want to invert it. Okay, so that's just inverting a 3 by 3 matrix. If you even knew absolutely nothing about the modelling, you should be able to pick up 3 marks here. You should be able to invert a 3 by 3. Okay, so the first step with any 3 by 3 matrix, you're going to want to compute the determinant. So I'm going to call that matrix M. You're going to want to, M inverse, so that means M has to be the matrix here. Anyway, so the determinant of M, that's going to be 0 of B0, 0.48, 0.96, minus 0 of 0.8, 0, 0, 0.96, plus 2 of 0.8, B0, 0.48. Well, these go to 0 because of 0, so it's 2 lots of this. So 2 lots of 0.8 times 0.48. It's 0.384. And then the b goes away because it's times in by 0. So the determinant times that by 2 is simply 0.678. Okay. Now, if I remember correctly, you then have to form the matrix of cofactors. It's cofactors, and then it's a matrix of minors, which is determinants of every single part. I think you can do it either way. I think perhaps. So the matrix of cofactors. So essentially, if you have the matrix entries here, you keep the signs. You flip the signs as follows. So around the middle, it's minus, minus, minus. Hang on a second. Apologies for that. So the cofactors. So you flip the signs in the entries in this way. So this matrix here. So so 0 minus 0 to positive 2 minus of 0.8, so that's minus 0.8. B positive B minus 0, that's just 0 plus 0 minus 0.48 positive 0.96. So that's your cofactors. You can call that no, no. I think you call it enter to C, but I don't know. It's just a matrix of cofactors. Then you want to do, and this is the really nasty bit, the matrix of minors. It sounds a little bit dodgy. So that is, you do the determinant of this is the A-level version anyway. You do the determinant if you say row 1, column 1 here for 0. If you, again, delete almost the row and the column, the 2 by 2 matrix you get, you need to do the determinant of, and you need to do that for all of them. So, we need to brace ourselves here. I'm going to make this a bit larger, actually. So, matrix of minors. I'm going to need more space here. Now, again, because they involved algebra, you can't just put it into the calculator as well. So I'm going to need a massive matrix to show this off. So it's 0 here, so you want to work on this bit here. So B 0 minus 0.48, 0.96. And then for the second one, minus 0.8, 0, 0.96. And then for this one, minus 0.8, B 0 minus 0.8, 0.48, sorry, hang on. Cool. And then for row 2, column 1, it'd be 0, 2, minus 0.48, 0.96. And then here in the middle, 0, 2, 0, 0.96. And then this bit here, 0, 0, 0, minus 0.48. And then here, 0, 2, a B0. And then minus 0.4 here is 0, minus 0.8, 2, 0. And then here it'd be 0, 0, minus 0.8, B. So then we need to compute all 9 determinants. Okay, but there are a lot of zeros, so that should help us out here. So that's going to just be 0.96b for the first part. That'll go with 0. 0.96 times 0.8 minus, and then that'd be minus 0.678, and then 0.8 times 0.8 times 0.48 is 0.384. And then obviously B0, that's 0, so that's that. 0 times that, and 2 times 0.48, and then that's negative 0.96. But then it's negative again because it's the other size. That's just positive 0.96. 0, 0, that's 0. 0 again, 0, 0, and then minus 2b here, and then 0, and then 2 times that'd be 1.6 minus 1.6 here. 2 times minus 0.8, but then another minus to account for the fact that you going that way. With how you can, so 2 by 2 matrix to bear in mind, just to say, it's AD minus BC. So the left to the right minus the other way. Okay, so that's where that comes from. As a refresher. Anyway, so that's that, and then this one is 0 and then 0. So that wasn't overly onerous. So there, so that's great. So then the final result, well, you just divide by the determinant. So 1 over, what's the determinant? 1 over 0.768 of this bad boy here. 0.96b minus 0.768, 0.384, 0.96, 0, 0, minus 2b, 1.6, and 0. Okay, what does it say? You could leave it as that, actually, I reckon. But do they want us? No, it just says determine in terms of b. So I believe you can leave it like this, or you could times it inside the matrix if you wanted to. So what's 1 divided by 0.768? It's not a nice number, actually. Well, you could. It's 125 over 96. Okay. So then, if you times that in, if you wanted to, you then times the determinant inside the bracket. You actually get, if you did that, 5 over 4b. That actually goes quite nicely, surprisingly. Uh, Times by minus 0.768. That's minus 1. Okay, we're getting. Okay, this should be the answer then, because we're getting nice numbers. Uh, that's a half, or 0.5. 0. No, that'd be 5 over 4. Well, 5 over 4 is 1.25. If we make sure, it's best to put it in the same way. So if it's in decimals, put it all as a decimal. 1.25, 0, 0, minus 2. Oh boy. That would be 125 over 48. This does not have a nice decimal representation. B, so that's minus 1.6 is, again, 25 over 12. Not a nice decimal, and 0. So that's the inverse. Let me check that's right, hopefully. Yeah, so, no, no, oh, hang on. Oh, oh, hang on. Hang on, what have I done here? Oh, I missed a step. My bad. What you then need to do, lastly, is consider the adjacent. So M inverse, that's not M inverse. Um, is the so you need to make the adjacent of this. Okay, so I missed a step. Yeah, I haven't done matrix inversion in ages. You could double check your answer, but you need to do the matrix of adjacent. So what I mean by adjacent, you is swap the row and the column number. So say this first bit 1.25b is row 1, column 1, so that'll stay the same. But this is row 1, column 2. So now this will be row 2, column 1. And then 0.5 are the same way, so 0.5 here. And then here, this is row 2, column 1. So this would be row 1, column 2, 1.25. And likewise, this would be row 3, column 1. So this is now row 1, column 3. That'll stay the same, 0. This is now row 2, column 3. So this will go to row 3, column 2. And then that would be 0, and then 25 over 12. Is that the answer? Let me have a look. 0.65. B, 1.25 minus 125 over 48. Yeah, I forgot to put, what did I, over B? What did I do here? What, over 48B? There we are. By taking adjacent. Minus 1, 0, 25 over 12, 0.500. Lovely, lovely. So that is the inverse. So yeah, so yeah, there's a lot of processes with finding an inverse of a 3 by 3. Hopefully, no, Okay, apologies. So yeah, so that's the process of inverting a 3 by 3. You need to compute the determinant. Then you need to find the matrix of cofactors, which is obviously the plus or minus bit here. You just need to learn. Then the matrix of minors, which is the determinants, and the adjacent. I don't think it matters what order you do them in, as long as you do each of them. But yeah, like I did, don't be like me and just forget the adjacent matrix at the end. So that's in, and then once you do all those three times by 1 over the determinant, you'll get your inverse matrix. There are other ways, but this is what they expect to. That's how they go through it in the textbook, and that's how they teach it in the spec. So I'm going to do it that way. There are ways like Gaussian elimination, and stuff like that, if you heard of it. But that's the method they want to see, I believe. Well, it doesn't matter, but that's the method it's covered in most textbooks. So I'm going to stick with the textbook to not confuse people more than they already am, probably. Okay, but I hope that makes sense so far, right? Not too bad. Obviously, part C is a bit manic with doing all the turbulence and stuff, but that's quite standard now. So far, not too bad, and we've done most of it now. We've got through most of it. Now, given that the model predicts approximately 215 mammals in total at the start of a particular month, so month, I was going to say month big N, but there's already big N there, so I'm going to call it month K. So month K. They don't tell us what it is, they just say it's a month. So approximately 596 newborns, 464 juveniles, 437 breeders at the start of the next month. So this is going to be K plus 1 month. Okay, let's break this down. So, um, again, let's write that in terms of math. So, 115 in month K, there's 115 mammals in total. So that means NK plus JK plus BK is 115. right? Because that's the total. So there are juveniles, breeders, and newborn. All those three give 115 in total. Then in the next month, K plus 1, it's telling us that 596 newborns, so month N plus 1, which is K plus 1 here. And the newborns is 596. Juveniles, JK plus 1 is 464. And breeders of BK plus 1 is 347. And that's the information we give it. And it says to find the value of B. Okay, so again, it's using the modelling. It's using the matrix again, the matrix system. So just more using the same sort of stuff, really. So again, let's copy our information that we were given. So what was it? NK plus JK, so month K. We were given this. Plus BK was some number, and then at month K plus 1, we are given NK plus 1 is some number. I can't remember it now. Let's go back. Lot of scrolling. Okay, so the total is 115. There were 596 juveniles. 115, 596. 596 newborn, sorry. Number of juveniles in month K plus 1 is what, sorry? 464 and 437 breeders. Okay, 464, 437. Okay, so that's all the information we're given, but we're given a month and the next month. So we just substitute this into the matrix model. So NK plus 1, JK plus 1, BK plus 1 is the same matrix here. So what? Remind what the matrix was. God, all this scrolling. By the way, if you want to do it again, well, this might take a while to stream. So what are you getting, an hour and a half or extra time? A lot of this is consumed by copying and scrolling for like minutes and minutes. So it's longer than it should be, and we should do apologise. But yeah. Anyway, so it's 002, 0.8. 0.8. I believe that was B. I think that was 0.48, 0.96, was it? Of NK, JK, BK. I believe that was the mod matrix, right? 0.48, 0.96. Cool. So what we're going to do, well, we're just going to use it again like we did in the other question. Use the same information. So therefore, let's substitute this in. So 596 JK, which is 464, 437 is 002, 0.8, B 0.48, 0.96 of, well, NK, JK, BK. Okay, there are two ways we can do this. You can invert it, take the inverse of this times by this, and I think we're going to do that, okay? I think that's the smartest approach. What this means, therefore, is zeros. I'm going to need more paper again. So 002, 0.8, B 0, 0, 0.48, 0.96, the inverse, times by 596, 464, 437. That will give us NK, JK, BK. Okay, so the only number we're going to get here is in terms of B. And then if we add them all up, we get a number, so we can solve B. So that's great. But we know what the inverse of this is, isn't it? We did this in part C. So remember, if you take the inverse, so a matrix system of like AX equals B. So X is the vector we're solving for. So here, so A is our matrix here, and B is the vector to solve. And we have another, we know the another vector B. If you times by A minus, you can get the vector solution X by doing pre-multiplying by A inverse. That is because A inverse A of X is A inverse of B. But obviously, this is I, which is essentially 1 in matrix, right? The identity matrix. So then you're left with IX is A minus 1B. But IX is just X, okay? So therefore, X is A inverse B, which is why we do what we do. So essentially, without the waffle, I guess, that's like the sort of little derivation. Um, because A is in front of this side, if you want to times by the inverse on both sides, because the order of multiplication matters, you have to keep the where it was the same. So if this is on the left of the multiplication here, you're going to have to times by the left here as well. So to the left of this matrix by the inverse. So you have to keep the order of multiplication the same if you're times by an inverse or otherwise, okay? Uh, um, So yeah, I'm gonna so let's substitute our inverse in, which is here, which we worked out. So 1.25b, 1.25 minus 125 over 48b. Uh, cool. Then you're left with minus 1, 0, 25 over 12. 25 over 12, not 12. Okay. 0.500. Times by 596, 464, 437 gets us our vector, right? A solution nk, jk, bk. So now essentially we just need to do the matrix multiplication. So to do that, I'm going to create another document. God help us. Okay. There we are. So. So let's work this multiplication out. Here we are. So the obviously you're only going to get a vector here. You're going to get a 3 by 1, so a bunch of a column vector, right? So that's going to guide us. So what you're going to do, 1.25b times 596 times 1.5 times 464 times this by 437. That's a lot, okay. So that's going to be 1.25b times 596, 745, 437. That's a minus 125. Okay. So if you do that multiplication, you get minus 18865 over 48b be 1.25 plus 580. Okay, I believe 580. And then for the second row, so that was NK. So then to find JK, minus 1 times 596, 0 times that, then plus 357 times 25 over 12. That's a lot nicer. Thank God. Minus 1596 plus 357 25 over 12. Gets us this number here. 3773 over 12. And don't worry, they're fractions, because bear in mind the question said approximately. So they're not exact numbers, so don't be afraid there, just to clarify. And then for the last bit for BK, times 0.5, 0.596. Add 0 times 4574, add 0 times 437. So it's just 596 times 0.5, which is 298. Lovely jubbly. Okay, 298. If it loads anytime soon. There we go. 298. And this is going to be equal to, obviously, NK, JK, BK. So now we equate them. So therefore, NK is this, JK is this, and BK is this. Now it told us that the sum, if you remember, NK plus JK plus BK at month K, the sum was 1,015, right, a month K. Remember that? It was up here, right? 1,015. They told us that in the question. So now we substitute our value for NK, JK, and BK. So therefore, minus 18865 over 48b plus 580 plus 3773 over 12 plus 298 has to be 1,015. Okay, so that means 18865 over 48b, and then move all the constants onto the right side. So 1,015, take away 298, take away that fraction 3773 over 12, take away 580, and you're left with negative 2129 over 12. So then B is simply 40 divide by this fraction here, so times this number by 40, the fraction minus 48 over 18865 to get this to a 1 to cancel it out. And you're left with this number here. B is 8516 to 18865, which is actually 0.51 0.45141. Now it says approximately, so we can just round this. So 0.51 to 2 dp. Okay. Because every other entry in the matrix is to do decimal places, so let's leave B as that. So that's our value of B. Okay, 0.545. So again, you're kind of just using the matrix model again, and that's the answer, yeah, at 0.45. Lovely jubbly. So again, you're just really using the matrix. Again, the numbers are a bit awkward, don't get me wrong, but it's what you know with matrix, right? There's not, you basically just, you're just working out the numbers, right? Which I don't think is the hardest. I think I don't, I think it's quite clear the numbers you need to use, right? How to convert this into math, right? To get these values, and then you substitute it into the matrix. Really, all you expect it to do is to invert a matrix and do matrix multiplication. That's really all it is, and you should know how to do that already. It's from the matrix chapter, right? 3 by 3 matrix multiplication and inversion, and then solving. Okay, all of that should be quite standard, right? So actually, how many? That's basically the whole question. It's just a 2 marker like reasoning question at the end. We'll go on to that after in a minute, but that's the vast bulk of the paper, not the paper, of the question, right? Fairly, I'd say, not. Yes, the numbers are bad, but actually, when actually you work out the numbers they're asking you to use, what to plug in, I don't think it's the worst thing in the world, in my actual opinion. Um, yeah, just work with the numbers and then use the system, and then it should hopefully kind of follow from there. Okay. But yeah, that is the process. I've seen basically a lot of matrix modeling questions. They all follow this sort of pattern, right? They want you to use the system to work out the some certain missing values in the matrix. So use matrix multiplication, start from n0 to n2. Do matrix multiplication to work out missing values. Then you invert it and then work backwards to find the first numbers. That's essentially what all the matrix modeling questions boil down to, essentially. So if you understand this process, what I've done here, um, so I guess to reiterate, we're given information at month 0, then we need to multiply to get month 1, then month 2 again. So then month 1 values are here, then month 2 would be here for the next month. Then we found A and then B0, which is the amount of breeders at the start. By then comparing the values you get after the multiplication, that not too bad. And then asked you to invert it. You didn't even need to do any modelling that. It just explicitly told you to invert the matrix. Then you use the inversion, and then on the flip side, invert this to find the initial values given the next month's data. And then that's again should be a fairly straightforward procedure. Again, not the nicest numbers, but um, it's the same sort of thing you're used to, right? Invert a matrix, solve to then solve, and then use matrix multiplication to get the next number. So that shouldn't be too bad in my opinion. But I do get this could throw people off. Like see all this wordy stuff at the end of the paper. Uh, but if you see it, don't just freeze. Uh, just read through it carefully. Think. Hopefully this should be practice, and you should know hopefully kind of what to do now after watching this. But yeah, so that's the bulk of the question. So but then let's have a look at part E. Okay. It's decided to monitor the number of newborn males and females as part of the study. So what's happening here is they're splitting newborns into males and females. So there's basically 2 variables now instead of 1. So I'm thinking, and this is quite typical, that when they ask you to refine the matrix model, usually, and then we're given at 42% on male. Uh, Usually, I'm going to do this in another document actually. Do we have any? No, we don't have much space here. Okay, let's do another one. There we are. Let's bring that over here. There we are. So usually the refined model, they basically want you to add an extra variable on, which means the 3 by 3 matrix will have to go to a 4 by 4 matrix because obviously 3 variables now. Newborns have been split to male and female, so we have to consider 2 variables now. So we can say instead, if we want to find the number of males and females, we can call that, I guess, m plus 1, f n plus 1, then j n plus 1, b n plus 1. Obviously define m and f. So m is the number of mn, number of male. What's it? Number of male newborns at month n. Fn is number of female newborns at month n. And so this is equal to, this is going to be a 4 by 4 matrix. Because a 4 by 4 times by another 4 by 1 vector, the column will cancel this to give another 4 by 1, which is here. So it has to be 4 by 4. So then that'll be mn, fn, like the same way, like we did with the earlier part, the same matrix model. Now, the question is, what do we put in a 4 by 4? And this is where it gets complicated. So, n plus 1. So, have a look at this. So, in a way, expand this out. I think it's good to multiply this out to see what happens. So, let's multiply this and see what's happening. So, it's saying each year, in the next year, how does it affect from the numbers of the previous year? What am I saying now? I'm chatting waffle. If we have information about this month's, like newborns, juveniles, and so on, if we times this, we get the information about next month's number of each. But then, so we can express the number of newborns and juveniles next month in terms of the numbers that were in the month before, and we can do that by just multiplying the matrix. So let's see what happens. So n plus 1, j n plus 1, and this is obviously for the previous version, but we can see what happens to then add to a new one. You see what I mean in a minute. So that's going to be, well, 0, 0, 2bn, and we did this actually in part A, actually, didn't we? Part B. We did this in part B, but I'm just doing it again. And then 2n, n, and then we have a and n. Well, a was 0.8, so 0.8 nn plus b, which was 0.45, was it? I'm going to do that here, actually. There's not enough room. nn plus 1, jn plus 1, bn plus 1 is going to be 2bn, a and n, which is 0.8n, n, plus b, which was 0.545 jn. Okay, and then bn plus 1, that's 0 and then 0.48 jn, plus 0.96 bn. Okay. Hopefully, I had to condense it. I had to put it on here. I don't want to write it again, but that's the model. So it's telling us that the number of newborns in the next month is going to be 2 lots of the current number of breeders. Okay. And likewise, the number of juveniles next month is going to be 0.8 of the normal, 0.8 of the current number of newborns, and 0.45 of the juveniles. Let's interpret that in context. So, 0.8 NN, so that's telling you 80% of the newborns become juveniles in the next month. And 0.45 JN tells you that 45% of the current of juveniles uh, remain juveniles in the next month, right? They don't progress to breeders, or they don't die out. You know what I mean? And then the number of breeders in the next month is 48% of the juveniles of the current month, so they become breeders, and then 0.96 of BN. So that means 96% of the current breeders remain breeders, so they don't die. So 4% of breeders die, essentially. So 0.96 live. So really what this is, if you interpret it, is the ratio of how many remain juveniles or how many age into the next category, essentially. And then obviously some factors into like how many die and stuff like that, but we won't go into that. Okay, and the reason why this is, and then to interpret this, BN, so essentially breeders in 1 month, on average, probably they produce 2 newborns, right? So breeders breed together, and it's saying that 2 newborns are formed by the amount of breeders there are. So for every breeder, in the current month, there are 2 newborns born. So that's that interpreted in context, okay? And that's what you can't. That's what they're kind of looking for this refined model, which is quite tricky. But like, it's only 2 marks at the end of the paper. It's not the end of the world if you don't get it. It's fine. But I'm just going over how you would approach it. And they're kind of the same thing every time. They love to ask about like animals. So I think last one was juveniles. It's that same sort of situation. Newborns, juveniles, breeders. How many remain juveniles? How many age to breeders? How many age to from newborn to juveniles? How many remain? How many breeders produce offspring of newborns and stuff like that? It's the same sort of thing each time. Okay. So these are what these numbers. So all of these numbers have meaning here. So we're gonna need so that we have not changed anything about juveniles uh and breeders, have we? The only thing we've really split up is newborns from males to females. Okay. So let's start with breeders. So breeders is in the next month. We need 0.48 of the juveniles and 0.96 of the breeders. So let's put that into our model. So obviously, if you think about it, 0 times mn, 0 times fn. Well, breeders, as we just seen, are not the breeders are not affected by newborns. So it'd be 0, 0 here because there are no male or female newborns that become breeders, right? So it's 0, 0 here, and then the numbers will be the same, which should be 0.48 and 0.96. And if you times it out, that'd be 0, 0, 0.48 JN, 0.96 BN. So that's lovely, lovely. Okay, now let's work this way. So juveniles. Okay, let's have a look at what this is. The juveniles in the next month have to be zero point 0.8 of the current newborns and 0.45 of the current juveniles. And then it's not affected by breeders. Okay, so, oh dear. Is that not going to be then? Not if there's zero point 0.8 newborns, is that not going to be 0.8, 0.8? Because zero point 0.8 males and zero point 0.8 females, that has to be 0.8. Because obviously the total number of newborns in a month is going to be the total number of males and the total number of females. No. Um. So zero point 0.8 of each. 0.8 NN is 0.8 of this and 0.8 of this. So it's 0.8, 0.8. And then the juveniles, the factor is, and then 0.5 juveniles remain juveniles, so 0.45 there. I'm doing the wrong thing here. This loads anytime soon. There we go. What was it? 0.48, was it? Oh god, it took so long, I forgot. What was it? 0.445 of the juveniles. Okay, 45% of the juveniles. And then 0. So let's interpret this. So every time the third row, 0.8 mn, 0.8 fn. So that's 0.8 of the newborns, which we already know, turn to juveniles. And 0.45 of the current juveniles remain juveniles, and 0 bn. You don't want to affect, no breeders turn to juveniles. So that's that row. Now we need to think about how we express the next number of females in terms of the current amount that we have. Okay. But we are told some information actually. We assume that 42% of newborns are male. So that means 0.42 NN is going to be uh, MN, which therefore means 0.58 NN has to be FN. Okay. So how does that work into it? Well, uh, again, I'm gonna jot this here. Oh, no, never mind. Okay. Oh God, what's this now? Even my laptop's done at this point. Done with it. Okay, my laptop's bugging out now. Forget it. Okay, so we also told that 42% of male, so 0.42 of NN. Let's get rid of this. Is MN, and therefore 0.58 NN is FN. Okay. How does that work with this? Well, let's use this. Let's use NN plus 1. Let's use what we did in part B. No, sorry. Let's look at not a part B. What am I'm waffling now. Ignore me. Let's use it again. Let's go back and look at here. So let's look at the number of newborns in the next month. That's just 2BN. Okay. So that's 2BN. Okay, so we know that 0.42 NN, MN is 0.42 NN. So actually, the number of, in terms of BN, MN plus 1 would be 0.42 of 2 of BN. Because we substitute NN plus 1 uh, into here, right? Into here. So NN plus 1, MN plus 1 is 0.42 NN plus 1. NN plus 1 is 2BN. So this whole thing has to be times by 0.42, which should be 0.84BN. Is that right? Likewise with FN, it's going to be 0.58 times 2BN. And that's going to be 1.16 BN. Okay. So those are expressions then. So we need this, right? So mn plus 1, so 0, 0, 0, 0.4, 0.84, 0, 0, 0, 1.16. So that should be a refined equation model, right? Refine the matrix equation to reflect this information, given a reason for your answer. So there's no need to estimate any unknown values, but any known values, well, they're all known, really, aren't they? Have a look at the answer. I might be off, but that's my sort of reasoning. Um, uh, but yeah, that should be good. As for a reason, uh, well, I guess the only it's hard to put this into words. I guess I, I don't know how give a reason for your answer. I don't know how you'd explain this in words. I'm going to be completely honest here. I've kind of explained as I've gone along to obviously help, but I said a lot of stuff. Essentially, essentially, you're preserving the percentages of each category in this in this model uh, as here, right? That's the whole idea of what we're doing here, and we're using this proportion to split up newborns into males and females. Uh, but given a reason for your answer, uh, uh, oof. Well, it's largely the same, right? It's just that these two values are different to incorporate for the fact that 42% are male and 58% are female. So I guess it's something to do with that. Ah, I'm going to check the answer as well, actually, one here. But first, a reason. Uh, that's interesting. Oh. Oh, there's no need. No, you don't need to give a reason. Obviously, you have to define your variables here, but they don't expect a reason. I don't know. They just want the matrix. So um, so this is correct. So this is, I think it is, but what they said here is the zero point 0.8 and zero point 0.8 are actually unknown values to give it as a question mark. But you can work them out, can't you? If you use this relationship, because this has to be true, right? If you add how many females and males there are, that gives you how many newborns there are. Newborn males and newborn females. Well, I'm not going to get into the whole debate about multiple genders, but I think for the purposes of this question, there are only males and females, right? Uh, yeah, but to get this value, yeah, this assumes there's only two genders because that's how you split up effect. Because if MN is 48%, 42%, then FN is 58% of newborns. So that allows you to conclude MN plus 1 is 0.84 BN and FN plus 1 is 1.16 BN. So yeah, so there are only two genders. So that means NN is just the sum of the males and females. Well, the juveniles, again, if you remember, is 0.8 NN, how many newborns there are, and 0.45 of the current juveniles. So that's right, 0.5 GAN. But they're not unknown. it has to be 0.8 either side. Well, I guess there could be multiple values, solutions maybe for that. Perhaps, but surely 0.8 NN, if you times by 0.8, both sides, that's 0.8 MN and 0.8 FN. No? So then that's 0.8 MN, 0.8 FN. So that should be right. I don't know why the mark scheme is saying that these are unknown values. You can work them out, can't you? Uh, or that. Oh, but yeah, okay. But it does say for the question mark can have any numbers in them. But I don't really agree with that. But it says for the unknown spaces, which is these two, uh, you can have anything, absolutely any number, even zero. But why is there more infinite solutions? Why can't you have multiple numbers here? Surely it's just 0.8 because the juveniles is 0.8 of the current number of newborns. But the newborns is again, like I keep saying, the sum of the females and males. 0.8 of each would give you 0.8 of NN. I don't really accept that, but I think that's the answer. But I guess the mark scheme's trying to be a bit lenient. But yeah, that's how you approach part E. I wouldn't worry if you didn't get that. That's probably me as well. I'm not explaining it the best. It is quite tricky to explain this, but hopefully, kind of somewhat made sense. But if you do want to tackle this sort of question, like I said, it's only 2 marks at the end of the paper. But usually, when they say refine the matrix model, they give you an extra variable to worry about. So you're going to need to consider a 4 by 4 matrix and to preserve the ratios. Okay, so do the multiplication, and then you need to preserve the ratios of all the variables. Okay, um, and that's how then you refine it essentially. So I kept the newborns to be two lots of the breeders. The juveniles is 80% of the newborns and 45% of the current juveniles. And then the next set of breeders has to be 48% of the current juveniles and 96% of the current breeders. That's how I've created my matrix. Okay, that's essentially what I've done there. And then when I split this up, I made use of this fact here that the sum and their proportions, and then I split it up accordingly. Okay, so that's that done. So you can leave it there. However, I did promise to look at this modelling question with the differential equations, have a go at that. Uh, but yeah, that's how you tackle all the questions that I've done so far. I believe these set of questions are probably the hardest it's ever been for further maths from what I've heard. 2023 paper one was the worst. We've just done it. We tackled it. We tackled it. Obviously, Bog said it probably had taken ages, but I want to spend a lot of time with the explanations rather than just breezing through it all in like I don't know, like an hour or something, with no explanations of what's going on. And uh, yes, that's the whole of working out. And obviously, also to say, I keep having to scroll up and create these documents and messing about because I'm on a computer and it's just a whole mess. So yeah, sorry, I know these are long, but they're for two reasons: to explain it well as best as I can, and obviously I need to go for some breaks as well to deal with some stuff. I do apologise for that, but also obviously it's just an absolute mess trying to write and scroll and do everything rather than if you have the paper there in front of you, it, it's a piece of pie to just keep copying stuff down and stuff like that. Anyway, so I'm going to look at this part A then as a final part. Okay, that's out of three. That's the final 3 marker. We need to use the information to formulate this differential equation, which is quite typical. and not very nice, unfortunately, which is why I left it till last. Okay, let's have a look. So the rate of flow. So the rate of flow is dV by dt. So there are V liters of water in the tank at time t minutes after the water begins to flow. So initially there were V, obviously T0, V is V, I guess. Water enters the tank at a rate of this litres per minute. Well, dV by dt, so the units are essential here. dV by dt is a rate, it's litres per minute. So the rate of the volume is going to be affected by this. So we're going to add so let's say per minute or per year. Let's say per minute. Let's say per minute. 3 minus 4 over 1 plus e to the 0.8t. 1 plus e is added. Okay. So this is the rate. So that means dv by dt is the we have to add this included. Then it says water leave the tank at a rate again proportional to the volume, so proportional direct proportion to the volume of water remaining in the tank. And so how are we going to form it? So volume water remaining in the tank. So that's going to be kV, right? kV is leave the tank, right? Leave the tank. Oh God. Okay. So let's go over that again. So every minute, so the rate of the water going in or out. This is added per minute. So this rate we add this on. So this is added to the tank, and every minute, it leaves water leaves proportional to the volume. So this amount leaves the proportion of the volume of water remaining, which is V, and then the proportion is kV. Therefore, the overall rate of water, also the overall rate is going to be dV by dt, which is going to be 3 minus 4 over 1 plus e to the 0.8t minus kV. And actually, it makes sense here. It's in the same form, but it's giving k to be 0.4. But we're going to have to show that, right? We can't just guess k is 0.4. But they're giving some information here. Given that when t is 0, the volume of the water is decreasing at a rate of 3 litres. So t is 0, dv by dt is minus 3 because it's decreasing at a rate of 3. So 3 litres going down, 3 minus 3. So substitute that into here. Substitute that into this little expression here. Therefore, minus 3 is going to be 3. Minus 4 over 1 plus e to the 0 point. Well, it's going to be e to the 0, isn't it? So it's going to be 1 plus e to the 0 minus kv. But we know what the volume is when t is 0. When t is 0, the volume is 10. So actually V is 10 as well. So we can substitute 10 for V. So just left with 10k. Let's simplify this then. So minus minus 3 minus another 3 is going to be minus 6. Plus 4 over 1, so that's 4. So minus 6 plus 4 is minus 2. That's there we are. No, sorry, 4 over 2. So that'd be 2. So minus 6. Minus 3 minus 3 is minus 6. Add 2 is minus 4. And that's going to be equal to minus 10k. That means k is 10 over 4, which is, and 4 over 10, which is 0.4, which is lovely jubbly, because that's here. So actually, substitute k for here, therefore by then sub k, therefore the rate dv by dt is 3 minus 4 over 1 plus e to the 0.8t minus 0.4v. And that's your answer. I think that's an extremely nice modelling question to form a differential equation. I've seen much nastier ones than that. That is actually fairly straightforward in my opinion. I should have done that earlier, but that is one thing that freaks me out, is formulating differential equations in a model. But that's how you do that question. So that's every single mark obtained. So yeah, I'm going to check for any questions now. Obviously, further maths exam is tomorrow, but if there are any questions with any questions about the questions that I've just done, I'll try my best to answer. I'll stay around for a minute. After that, I'm gonna leave you. I'm gonna publish this on YouTube, so then you can watch any part anytime. I don't like the way Twitch does it. I think the way YouTube does it a lot better, but this will be on my YouTube after this, and then in the morning, if you want to, if you want to test your knowledge on a hard question, if you're struggling with a particular topic, look back on here. Hopefully, I've explained it so you understand it. Look back at the working, and then you can use it to help you. But yeah, that's 2023 paper 1 done. I'm going to stay around for a few seconds now. But as I say, I do apologise. I did answer them in the end, but obviously I had to go away for a little bit. So if I didn't answer some of your questions, I do apologise. But also to iterate, this is part 2. So part 1 of this paper, when I did questions 1 to 4, is is also up and available. Okay. So these are the indicators. So part 1 is questions 1 to 4, but I assume a lot of you will want to look at part 2. These are the hardest 4 questions, probably one of the hardest set of questions on the further maths paper. So this will really, really, really test your knowledge. Okay. So that's this stream here. This is part 2. This stream. Okay. It doesn't look like there are any questions here. Okay. I'll try and answer some of the earlier ones. Again, just to answer it again, so everyone. So if anyone does come back to the stream and scrolls to the end, obviously I've answered it. Keep it up. Thank you. You're doing it way better than I did last year. Yeah, just to iterate, I'm not a student, by the way, but I'm also not a teacher or tutor. In between. So I'm someone who did a degree and I've been out of it for a few years, but I still remember my maths. But uh, sometimes it takes me a little bit of time to jog my memory. But I'm getting better and better at it as I do more of these past papers, and eventually I'll be great. But I'm also getting used to doing it on the digital pen. Because I've never done this before. Really, I've done a few of these streams now, but I'm still new to it. I'm still bearing my feet. This is the first further maths bit I've ever done. I've not done this sort of stuff in years now. I've not left uni in years. I've not done A levels in 6, 7 years. Um, so yeah, I guess a bit rusty, but I just still do know how to answer the questions. I have my knowledge still there, and you know what? That might help people, so that's why I'm doing it. And I think that's good as well, especially if you've not done maths in a while. So the way I approach it's kind of like the logical way of approaching it rather than just learning formulas and learning a method. So I guess the way I'm doing it's kind of the intuitive way of doing things, which might make it easier than just memorizing a certain method. So if you listen to my explanations, hopefully that might help why you do certain things. So yeah, so to clarify, I'm not a student, but I'm not a teacher either. I'm in between. I've done this before. I did my further maths A levels and all that ages ago, but now I'm here to help. A few years later, are you sitting the paper tomorrow? No. So to reiterate, I'm not. I'm not a student. But good luck to those who are. Um, does the king read the chat? Oh, you know what? I don't. And I do apologise, but I didn't see it then. But I'm reading it now. Uh, yeah, the king. He's locked in. Wow. I'm glad someone thinks I am. No, but I don't know. I'm just going over the paper and giving my thoughts on it, how to approach it. I have it tomorrow. Do you? Oh no, you have the paper tomorrow. Good luck. Uh, good luck. Good luck. Hopefully this helped. I'm just here for support. You know, so am I actually. To be fair, so am I. I don't know. If I'm good support, then great. But if I'm not bad good support, I don't know. I do apologise. British boyo sounds like a. Okay, no, let's not have that in here, man. Don't do that. I'm okay. Don't bring each other down, man. No. Do you think a reflection question is going to come up? Oh yeah, just addresses. So it's not a common topic. So if I'm asking about if a reflection question is possible, not likely, I would say. Uh, but it's always helpful to revise it. Because you never know, there might be a 7 marker on reflecting the line, and you're like, oh, that's 7 marks down the drain. You could have potentially just learnt the method too. Uh, so yeah, I think Mr. Bison does a video. I don't think the textbook does it very well, explaining reflection of lines. If I'm honest, obviously you can use my video to that particular question. It was question 5, wasn't it? 5B. That was the reflection, the line question. If you want to go over how you tackle an exam question. On reflection of lines. But I think Mr. Bison and a few other people, if you look them up, they explain the topic as well. Yeah, not likely, but when they do come up, there are a lot of marks, so you got to wait up really. But but I will always say though, learn absolutely everything, every topic. Like you never know what will come to bite you. Just revise it all. Um, But yeah, I'm gonna leave that there then for now. It's coming up to 4 hours. God, obviously don't spend 4 hours on your exam, but obviously I'm taking longer for various reasons. But yeah, hope the examples helped. I will publish this on YouTube so you can see it before paper 1 or paper 2 or any other future people doing further maths. This will be in the ether forever. So you can use this at any time as a revision resource. So this was June 23, paper 1. I heard the hardest one ever. I don't know about that, if I'm honest, but definitely a very tough paper nonetheless. But that's how you approach it. But I'm going to leave that there then. So good luck for Tuesday if you're doing a paper. But I am going to leave that there.